DesignMorphine's journey started back in 2014, and through this creative platform, we are able to connect with people, empower them, and fuel their passion for collaborative design. We had the privilege to have taught thousands of specialists from all over the world and nurtured their progress in some of the biggest companies in the world. DesignMorphine is a catalyst for collaboration with people who we admire deeply as individuals and also professionals. The team is comprised of 43 talented architects and designers and a number of collaborating organizations, which gives us a multidisciplinary approach to design and its education across a gradient of applications. We are a community dedicated to academia, but we are also all professionals who practice our craft daily, and this allows for versatility within the team, but also we are in a constant state of learning and bettering ourselves. Some statistics. We have taught students from over 82 countries. We traveled in so many cities around the globe, like Dubai, London, Vienna, and many more. We created projects on many different topics like robotics, virtual reality, and many more. Our pedagogy surpassed the teaching of technical skills since we always challenge our students to give their best. First and foremost, we are a community. And as such, we support our students' dreams and we empower them. Many have been accepted to universities like Harvard, the Architectural Association, SCIARC, or have been accepted to work at the accredited Architects, Foster & Partners, Nike, Moonray, and many other reputable offices. Some past examples of our students' work on multiple scales and topics like jewelry, architecture, installations. One thing always connects them, and this is the experimentation and unique workflows. And as you may see, we are heavily invested not only in the virtual world, but also in fabrication. We also collaborate on product design with our partners. And one example that I'm sharing now with you is with the amazing Arturo Tedeschi. We created this suspension lamp called Horizon, which encapsulates a freeform 3D printed shape within a handmade glass shelter manufactured in Murano, Italy. It was also exhibited during Venice Glass Week 2020. And if you are interested to learn more about DesignMorphine and our newest endeavors, you can always check our social media channels and also our website.
So today I'll start with something that is in the core of DesignMorphine, which is computational design, and which is actually the application of computational strategies to the design process, and it aims to enhance the process by encoding design decisions using a computer language. So isn't the computer actually using a computer for design, a computational design, that one might ask, and it's actually a great question, and that's what we're here to answer today. So basically, in the beginning of the profession of architecture and design, designers drew by hand, and each stroke of the pencil was informed by the need of documentation. And as technology advanced, drafting boards and pencils were replaced by computers. However, the process of design and documentation remained exactly the same, only the medium changed. And that's how we arrived at something which is called CAD, which we all probably know. It's a computer-aided design, which is essentially copies existing physical actions into the digital. So the computer is treated as an aid rather than a contributing part of the design process. This is a chart of the most used CAD commands and which of those are mostly used together. And if we do all these commands and understand the repetitive processes and patterns of how we use them and how we can actually optimize the design workflow in a way that lets the power of a computer truly help the design process. And we arrive at the beginning of computational design thinking, which is defining the parameters and rules of design. But having the computer processor executed, design becomes a series of operations that can be adapted to multiple situations and conditions. Computational design is nothing else but actually a mindset. And a great example, it's actually this of Antoni Gaudi's La Sagrada Familia, which is an ecosystem of geometry that emerges by the set of rules led by the structural stability of the stone. The geometric language was documented in manuals that were destroyed during the Spanish Civil War. And today, computational design is the key to restoring the original design intent, since the building logic is encoded into the already existing structure of the church. Contemporary extreme case that we could actually look into is the Sports Hall of Fame by Trajan Architects, where a computational structure system was defined and was able to adjust itself to changes in the architectural form. The rules of the system create the structure, the architect creates the form, and sometimes the computation will restrict the form so that the structure can work. This helps prevent the designer from making mistakes, as well as frees up much time from mundane tasks and lets the architect think more about the big picture gestures and actually the design process. So computational design can be applied to any design field, and that's what it's exciting about it, not only to architecture. And here we can see a great example of Zaharit Architects and Stratasys developing a custom workflow with repeated iterations between design and structural analysis. And it also utilizes material saving parameters developed by Altair Technologies. And in the video, we can see the program with parameters that they developed in order to allow the visualization of this chair and how it would look in different colors and with more perforations, etc. So it's quite an exciting way to think about design. It's very different from the conventional way of using a computer, right? And you can see here exactly like all the data that it's changing according to different parameters at each time. And structural stability, which is running, and it's a very important part of the design. So computational design enables you to automate the repetitive tasks, as we saw, that lets you prove your design decisions with real data and forces you to think of design in terms of chunks of processes that can be used in many conditions. And the best part for me, it's that computational design is multidisciplinary, it is multiscalar, because it allows for this mindset to be applied across all industries of design. And that's what we see today. If we take a step further into the fusion of multiple software and hardware and use them unconventionally, that's where you find the most breathtaking and truly innovative design ideas. So we are excited to talk today about our actually first year of our fully accredited Master of Science in Computational and Advanced Design. And the program is specifically crafted to be online. We aim to prepare the new generation of designers to thrive and drive progress and change in design, especially now when the fabric of all design industries reality is changing by the rapidly emerging new technologies. So computational design is actually no longer just the profession of the future for all creatives, but it's relevant right now. And we see that with leading companies hiring for computational and advanced designers and creating these teams, because they do see the value in that. The mindset and techniques and software taught in the program can be applied to any creative field, and that's the beauty of it. And this is vital because it allows for this great versatility and diverse professional experiences. And this is the first year that we actually have the program running, and it's really a privilege to be working with 38 incredible designers and architects from all corners of the world. The distinctiveness of the program lies in some of these key elements that you know, I'm going to mention actually. And you basically get the unique opportunity of experiencing these different industries, as I mentioned: fashion, industrial design, architecture, urbanism, vehicle animation, robotics, all through the lens of computational design. It allows you for great flexibility because it is online, and it is crafted to be an online educational experience. And as such, it requires no additional expenses like model making or printing or 3D printing, with the only exception of the prototype, where you will be creating your own swarm robots or robopets. So we are actually applying our own accelerated pedagogical methods that allow students to absorb information efficiently. We've been working with DesignMorphine for 8 years now. So we actually, you know, like we actually thrive into teaching new software to people with zero experience. And it's been more than basically 15 different softwares that we're actually teaching in the program successfully. And also, new students will gain access to over 30 educators and mentors and real life professional experience from the best companies and universities in the world. It's something basically unprecedented for a Master of Science degree. And also, in all our chapter presentations, we do include our community, and 2 months into the program, students have been receiving job offers from eminent companies driving the future of design and receiving awards for their work from, in the program. That's, you know, the first year that we're running, and only 2 months into that, we see such success. But most vital, of course, is DesignMorphine's disruptive nature and this fearless drive to build a united design community that will be part of your growth as designers perpetually. So the program is fully accredited and worldwide recognized by the University of Architectural, Civil Engineering and Geodesy, and the university that, as we mentioned, Svetlina and myself studied at in Sofia, and we're doing our PhDs right now. And the program is organized in a unique way. It's based on 5 leading design chapters and 5 supporting labs. They're technical and theoretical, and the whole program spans over 9 months. The chapters are 5 weeks long, while the labs 1 week. And each chapter follows the following rhythm. We start with the first week, where we have the theory lab. So students are formulating their own vision, and they follow through the whole program as they're taking charge of their own projects, expressing their own voice. There is no right or wrong approach, but you will be called to envision your own scenario and defend its relevance and value. Moving into the next week of the chapters, we have pre-recorded tutorials and one-to-one time with your core leads, and you're preparing for the design phase of the chapter, which is in weeks 3 and 4. And during the leading design chapters phase, that's where students respond to their scenario and start with the generation of the enhanced human body, and then they progress into the development of more complex architectural entities and build global systems and networks, reaching the final state of cosmogony throughout these chapters. And week 4, it's where we have presentation preparation, where we invite again our partners and community, and it's a great way to gain exposure to this community. So I will go through the chapters and give you an overview. And again, like, don't hesitate to ask any questions like about any specifics that you're interested to know. Chapter 1, it's about prosthesis. So everything that humanity has designed so far is based on the way that our bodies are designed. And the prime focus here revolves around this technological and cultural prosthesis, since technology can and eventually will shape not only our minds, but our body also. So we start with a scenario-based approach and envision the fundamental element, the human body, and the technological future this body will operate within. We're looking into cyborgs, half machines, and augmented beings. Actually, like the focus here as we start the program is actually polygonal modeling, Maya and ZBrush. They're used in the animation industry, but they're actually used in the footwear industry and also architecture at Zaha Hadid, at Mata Architects and other offices. So we have moving into the next chapter, we're actually, the scale is going up and we're working with what we call a corpuscle. So the corpuscle are the living conditions and spaces that the body requires. And we work with interior and exterior challenges, and we have to answer questions about ephemerality, mobility, adaptability, transformability. And this chapter is focused on component-based design and user interaction systems. And again, like we're moving now from polygons to the interoperability of Maya and ZBrush through Rhino, with NURB subdivisions and also Grasshopper. It's a unique workflow, which is really empowering because it just gives you the ability to really make anything you imagine. In chapter 3, which actually we are going through with our students of the first year right now, which is a very, very exciting chapter where we're looking into what we call these living cells and how they actually develop and create communities and clusters. So it's the very question of what constitutes a community of people. And we also examine how external conditions impact and shape these living and public spaces. We're looking into generation and optimization of rule-based structures. And here parametric design is the lead, parametric design, generative design with Grasshopper. So we're really diving deeper into the computational design in this chapter. And moving into chapter 4, that's what is kinesis. And as you can imagine from the name, we're focusing here on vehicles and expand into various complex structures weaved together by transportation and mobility systems. So we're looking at horizontal, vertical, underground, organic growth-based systems. And now we're moving from Maya and ZBrush towards Houdini and particle simulations and flows, which is something quite exciting because Houdini is really, really taking over because of all the abilities that the software has dealing with very high complexity. So it's a great opportunity actually to work with it in chapter 4. And last, we have chapter 5, and all these previous stages are leading up to this stage in which we develop and access the larger scale of our envisioned worlds, the city. So by zooming out, new challenges arise in terms of increased complexity, and encoding behavior will be the primary focus. So we're looking into C#, agent-based growth algorithms with Grasshopper, and programming also with Visual Studio. So we're really going into creating these complexities that Grasshopper is going to enable us to do. And as far as the labs are concerned, as I mentioned before, you are going to start each chapter with a theory lab. So it's an absolutely essential vertebra of all leading chapters. Is the main focus will be evolving with this theoretical frame across these 3 different axes. We'll be looking at symbiotical relationships of new bodies with AI, emerging complexities of the new cosmos, and ways to collaborate with and utilize patterns and behavior of the natural environment. And there is no predefined or given solution, no predefined truth. And this deep lab is basically a place of exploration. This axis of the theory development will be given, but some foundation to build upon. But the exploration of the structure and how it ties together will be up to the students. And we work with plethora of diversified materials like books, movies, anime, games, really TV shows, anything that actually inspires our generation and makes sense to you. We want to hear your voice. We want to actually empower you to be the best designers that you can. And that's what the theory lab is here to do. The prototype lab, here the main focus is basically like going through prototyping, laser cutting, 3D printing, CNC milling, and vacuum forming. And the students are gaining an understanding of these machines, and they learn how to prepare their digital models and optimize fabrication processes. Also, they learn how to utilize visualization software like Shape Diver and other tools that outline a novel production workflow. But students will submit the visualized version, so there is no real world model as an expectation from you. And we prepare the files for exhibitions basically when needed, and we print them, so there is no expectation whatsoever about like actually creating this 3D printing these files, since the program is online. The media lab, again, an amazing opportunity. We have V-Ray actually coming into teaching the first phase about like rendering with Rhino, Grasshopper, and Maya. And in phase 2, there is the post-production with Photoshop. We will be creating unique styles of rendering with a personal touch and obviously attention to detail. And we have also the robotics lab, which I mentioned earlier. This is especially important to understand the kinesis part of the master's program, because we're building here multifunctional small robots, so what we call swarm robots. And we're actually designing them by specific conditions and rules. So we use sensors of sound, luminosity, and movement. So we're dealing with aspects as much as material properties, geometry, structure, joinery, assembly, programming sequence, etc. And this is actually the only part that you will be called to get the materials and Arduino in order to make your robot at home. And actually, like it's a lot of fun actually making those. And moving into virtual reality, that's another amazing lab that we're looking forward to with the students, and that's actually very relevant right now with everything that's happening with the metaverse. So basically, it's how to shape these digital projects into an experience. This lab, the students will learn to utilize Unreal Engine and turn their projects into interactive VR models, and this is like to make enticing animations, to demonstrate one's concept of from the chapters. And this is basically like an overview from all chapters and labs, and I'm looking forward to some of your questions later on. I'll give the word to Michael. And we'll have also some of our students present some of their projects soon.
Thank you so much. Yeah, so I just want to kind of go over a bit and share a bit more in general. And I see some questions already, and we're going to definitely get to that. But keep asking away in case we miss something also. So about the program, I just want to firstly say that, it all kind of starts with this theory lab, right? That's kind of like where this all begins. But I just want to make clear, obviously this is a theory master's, right? It's a Master of Science, which is a technical degree, right? In computational design, right? So in the lab, you'll develop the theory of your scenario for the entire master's, right? So this entire lab is where you kind of develop that framework, and you're open, to develop that framework. Like, we want you to be your own kind of individual and have your own ideas, and we can help you kind of cultivate those ideas. And these can be whatever. They can be utopian, dystopian, metaverse, physical, fantasy. We have all kinds of this already in the program. And then kind of this scenario paired with the design scale of each chapter is kind of how you'll focus your computational design thinking. So, you know, the goal of the theory scenario is so that you're not kind of aimlessly making random computational geometry or pavilions, whatever, for no reason, right? So it's to give you a focus on the actuality of what your theory is. You know, so you know, the actual theory is not kind of the primary focus as much as the technical education, right? So the master's is primarily about learning to be a problem solver and thinking in many scales, utilizing computational strategies and various industry standard software. So, you know, in the end, we want you to get these kind of jobs and be proficient with these kind of desirable tools in the market now, not necessarily to be, you know, a theory professor. So just to reiterate, there's a theory that you'll decide and develop, but it really serves as a vehicle to focus your technical studies. And since we do not force a specific theory on you, you'll see that each project, even in the small selection that will be presented today, each project gets its own life. You know, like we don't want to be a kind of place where the work ends up just looking kind of like the tutor's work, right? Because that's not really helpful for you as an individual trying to market yourself in the industry. Let me just share here. And I'm going to start here because while we're on that, talking about kind of like industry professionals and whatnot. So, you know, you can see here the roster. We have a few more people we're thinking to bring on, especially as mentors. But everyone here is, you know, the main goal for us when we were kind of trying to find these people are people that are actually working in the current industry, doing current work, right? Relevant current work. That's kind of our focus. And it's the same for the most part for our reviewers as well. Like, you know, when we have people on reviews reviewing your work, these are people that are able to hire you, able to network you, able to get you around. As Pavlina has mentioned, we've already got multiple students getting job offers directly from our master's degree and the presentations and what we're posting. It's not indirect, it's actually quite direct. You can, you know, ask them yourselves. We had a few students win awards already for the, you know, with the skills they've learned directly here. So that's kind of like our focus is kind of like staying relevant in kind of the industry and what's going on here. And that's also how we choose the software that we're teaching. You know, we choose software that is, you know, of course, there's many softwares that exist outside of our program that can do similar things, same things, but we're trying to focus on the ones that that companies and hiring places are using, right? Like, so you want to be educated in those things if you want to be kind of marketable in the industry. So, you know, the kind of idea of this is you know, in general, you go through each chapter. You know, of course, you define this theory, and then you're going through each chapter, and you're designing things at that scale based on, you know, based within your theory using computational tools, right? And, you know, the very first one, and computational doesn't always mean like hardcore programming and stuff like that, right? It's a way of thinking. So, you know, if you want to learn these tools the proper way, you know, you have to start with understanding kind of like the manual way, the basic way. And that's kind of like our first chapter, why it's Maya and ZBrush, because you need to learn how to control these things manually before you can control them kind of algorithmically, right? So that's very, very important to understand those things and how they work in a manual way first. And at that scale is the kind of human scale. You know, in the next scale, we do also, in the beginning, we're teaching a bit of manual Rhino, right? Like you have to know kind of, if you know how the software works, you can know how to use it algorithmically as well. And in that scale, it's more about the scale of kind of housing, living environment, capsule, and also product, right? And then in the next one, amalgamation, is about deployment, computational deployment strategies. How do you, place things computationally? How do you arrange them? What are the relationships between things? And that's at a neighborhood scale. And then kinesis, which is about transit and vehicular design, right? So another kind of scale. So, and then cosmogony, which is more, if you will, consider it like at the city master kind of overall scale. And these scales, we start from the inside out, right? Like we get super hyper detailed and specific, and we keep zooming out and out and out and out. And you're kind of just building up this whole thing. And at the end, what you'll have is this whole kind of, book of a coherent project that you're not, you're designing in stages. So it's less overwhelming than trying to figure this out all at the same time, right? So the chapters are always related. In your book, you'll see, okay, this is the cosmogony. What were the, inhabitants of this cosmogony is kind of coming from the prosthesis, and what kind of, vehicular design and whatnot. And so that's from the kinesis. So it's kind of all interrelated in that way, from beginning to end, which is, I think, a really nice thing to kind of always be learning new stuff, having new tasks, but in the grand scheme of things, being kind of consistent with the topics that you're thinking about. And I just want to reiterate, again, this is a computational and advanced design technical degree. It's not an architecture specific degree, right? Like, so there is architecture, but it's not only architecture. So just to keep that in mind, a lot of our students, even from Y22, they're not architects, right? We have people from all different kind of industries, and that's the kind of beauty about computational design is, having these skills and this way of thinking, you can work across a gradient of industries, even all at the same time. I came from architecture, went to product design and sneaker design, and now also working in like metaverse design. There's just like all these things you can do with the kind of these skill sets. I just want to point out, if anyone doesn't know, if you haven't looked at the website, we have a whole bunch of Q&As down here that you should definitely check up on. Two important ones I just want to touch on real quick, which I see here, is about the programs, right? Different software programs. So we are an accredited degree at a university, which means you get university email, you get all that stuff, which also means you get education rights for software. Almost every software we're using is free with an educational email address, official educational email address. So almost all of them are free. I think the only ones that aren't free are Rhino and ZBrush, and if I'm not mistaken, maybe Adobe, but they're all like, the ones that do cost money are super cheap. I mean, the Rhino, I think, goes from $1,000 to like $200 because of the education, right? So it's not an insane cost. But then like the big ones like Maya that are like, or Houdini that are like insanely expensive programs, they're absolutely free with that. So it's not much expected cost in terms of software, because you're actually a student of a school. Unlike, say, like a webinar or a workshop. And we're all we talk with all these companies. We make deals with them and whatnot. For instance, the recent one was with Keyshot, because technically on their language is something different about what you can be to get an education license kind of old school, like have an ID and whatever, and we just talk to them like, hey, it's online. Students don't have like student IDs, whatever, and they're like, yeah, that's fine. Just send us this kind of letter, and so we give you all that letters and everything you need for every software and to get your stuff. The other big one is about which you know, just talking about like technical stuff is like the computer specifications, which you can find here. This is kind of like minimum specifications. I said, you know, we always suggest to get, you know, the better you can. As our students found out very quickly, graphics cards are super important when it comes to visualizing your work. Most of our students have gotten good graphics cards afterwards, already had them, and some students are even using cloud computing for visualization, which is not that expensive, especially because for the amount of rendering you'll need, like it's kind of like for final rendering stuff, a lot of those cloud computing companies give you like free credits when you first sign up and all this kind of stuff. So those are kind of two important things just in like the technical stuff. I mean, there's a bunch of other stuff here, but I just wanted to like specifically point those out. Now, the way that this done on a part-time basis. Yeah, I think we can get to some of these questions. Then it's probably better to answer some of these. Definitely get to them. So keep asking them in there, and we will. I answered this one about the software. Keep asking them there. We'll try to find the right moments to answer them. So the way that this works. Firstly, I just want to talk about kind of a bit about our ecosystem, which is primarily in Teams. And I'm just going to hop over here real quick. I'm not going to go through all this, but as many of our students have told me and told us, even on the first day, that I think almost all of our students said that this was the most organized degree program they've ever been to. I mean, you could ask them, they're here somewhere in the chat. They're just like amazed at how organized and how simple it is to follow. I mean, we've organized everything so that you never don't know what you have to be doing. Down to the tutorials and everything. We have like when you should watch them, how you should watch them, where to watch them. It's kind of like a whole list, when to do things. Everything's super organized. In Teams, where, simply by chapter, by lab. And for instance, like in this links here, I'll just show this. Again, this is all subject to maybe micro changes by the time you might join our program, but it's pretty much going to be something like this. And it's very easy to find everything. You want to see the program, you want to see your teammates' info, you need to contact somebody. Primary software. So this list is, and click this, it's an entire list of all the software, which is on our website, but also where to download it, what you need for the education license, how much it costs, or if it's free, all that. All the Grasshopper plugins you'll need, how to install them. Tutorials, big one. So this is just a big list, and it says what tutorials you should be watching for each chapter, when you should be watching it in that chapter, how long it's going to take to watch it, and where to watch it, of course. And those videos, the ones from us pre-recorded, live in streams, right? So they're only accessible through Teams. And yeah, and we have a digital library as well, because of the university, where you can access all kinds of books and all that for free. Yeah, so that's basically kind of how that works. So Teams is the main kind of portal for communication. As you can see here, we're currently in amalgamation. You see the kind of chats kind of always rolling. Let me just do a little refresh there. So the chat's kind of always rolling, questions always being asked, questions always being answered. It's always going 24/7. But so the way the program works is basically in the beginning of each chapter, you have a week to define further the theory for that chapter, right? So you have this whole theory you've defined within a month or so, and then you're spending the first week like micro refining the theory for that chapter. Then you have another week that's completely free. It's open, but you're still working. And in that week, you're mostly like watching tutorials, experimenting, exploring, trying to understand the tool, right? And then you have about three to 4 weeks of the tutors, right? So every day you're meeting with the tutors, they're critiquing your work, they're giving you advice, they're giving you technical help, they're showing you kind of extra tutorials. So that happens every day, Monday through Friday. So it's like an everyday kind of review. Each team gets like, X amount of minutes. And that's kind of how we do it. We do it in those 3 weeks. It's like very everyday, like to get you where you need to be, get you focused. No one's like kind of like struggling or like lost, or right. It's like checking up every day, getting the awesome stuff done. And if I, the other big part of our program is Miro, right? So that's where a lot of this happens, all the work happens. And so for Miro, we have basically the chapters have 2 different Miro boards. There's these gray ones, which are the work in progress boards, and then there's the colored ones, which are the final boards, right? Final presentation boards. And then labs only have 1 board because labs are treated more like workshop style. There's no presentations for labs. You're really just learning, right? So they're more kind of rough working through kind of boards. I'm not going to click it from here because it'll take a minute to load, but I have some loaded up already here. So this is kind of like what a board. This is a Kinesis board, which we're not at this chapter yet, just so you can see what it looks like when it first starts, right? Every team, has their board, it's blank, and we go from there. And so if I look at this, this is the board for the first chapter, that one of the chapters we've done already. This is the work in progress board, right? So you can see tons of work in progress, sketches, notes, comments, and you can see, because I had the tab closed, things are still populating here. So that's basically how that works. Just it's very work in progress, desk crit style, notes, sketches, all that kind of fun stuff. And then once that's done, there's the presentation boards, right? So you make your presentation also on Miro, and I can see some students here poking around. So that's very presentation style here. So you're not making like extra presentations like PowerPoints and this and that. We do it directly through Miro, and we present also through Miro to the critics. And that's basically kind of like the workflow of those. And so then the other thing here is I just wanted to show like what a lab looks like, right? So labs are kind of like they're more experimental. They're really teaching you like the things we've defined. Like Media Lab is going to teach you how to render, so they're not necessarily like part of the design chapters, but they're important things, right? Like everyone needs to know how to render good, and should know how to like fabricate and stuff like that, right? So and these are very also like work in progress. They're like the work in progress boards, right? But they don't really there's no presentation for them. And yeah, so that's basically kind of how that's working. The kind of organization of our whole system there. And last thing also is, at the beginning of each chapter, we fully write out kind of like what the deliverables will be at the end of that chapter, right? So you're never surprised, right? So we want you to all the time be knowing what's the goal, where you should be arriving at, and what you should be doing each day. We don't want you or anyone to spend any time feeling like they're not sure what to be doing or feeling lost, right? So that's kind of like our goal here, and to get this stuff done directly. And I guess the last part before we start getting to the students that I'd like to mention is that we currently in this iteration we have two groups, A and B, because obviously students are all around the world, right? So we have two different time zones. So these everyday reviews happen actually twice a day, but you would be in one of them, either group A or group B, depending upon where you live in your time zone, right? We don't want anyone, unless they really want to, being in class at 3 o'clock in the morning, so so we have two different groups to accommodate different time zones. And yeah, how about anything else you want to say, Lena, before I
No, I think that like we went through a lot of the most important things. I think that we had some questions about how long is the time frame. So basically your live sessions that are mostly during the labs and the chapters, not the gray weeks that we're saying that it's your own time to watch your tutorials and meet with the core leads that are with you throughout the whole process. But you have a maximum of 4 hours, depending like online, which of course like give you the opportunity to talk to the tutors, get feedback, ask any questions, work with them. Sometimes actually the chapter leads do open the actual files to help out with the design process. It's your own design process and you're leading it, but you're getting all the support from all these aspects, either like through Teams with asking just questions and putting the files there and getting answers, or through your live sessions, or again like talking to your core lead, which these are like they're absolutely amazing. They're we have 2 core leads that are working with the students full-time throughout the whole process, and then the chapter leads are coming for the specific chapter, right? So there is a lot of opportunity to meet all these people. That's why the program is structured that way, with amazing educators from over the world working in different industries, and they're the best in what they do, and that's why they are in this chapter through the chapter that they're focused on. And the leads are there, the core leads are there for you throughout the whole program, as well as the core team with Michael, myself, and Svetlina.
Yeah, and actually a good question. Belmonte, apologies if I don't pronounce that. Oh, I see you already answered it, Lena. Yeah, but yeah, there isn't like there's not like a thesis or final project to focus on, because the entire thing is the thesis and final project, right? Like that's the entire thing is that. Actually, I think I want to answer a few of these questions before we continue, because I think they're relevant now.
Okay.
But I'm not sure.
So one of them is if the masters can be taken basically part-time, on a part-time basis, and if it's taken for a longer duration, yeah. But no, the masters it's for 9 or 12 months, depending on your educational degrees. So when you actually apply for the master's degree, you do have like some questions about some ECTS points in your past experience, and you have 3 different paths there that you can choose. One, it's actually has to do with no previous degree. You're very passionate about, computational design, and you want to be educated. We want, our door is open to everyone who wants to progress. So even without actually like a bachelor's degree, you could take the master's degree, but without a master's diploma. And then you have of course, like everyone is applying for the master's degree with their design portfolio, right? You might not have a bachelor's degree. That doesn't make you, less of a designer. So that's why we think that like some people really should have this opportunity to get educated even on this level. The only difference is that you wouldn't be able to take your diploma, but then you have an option for 9 months and an option for 12 months, again, according to the educational degree that you hold beforehand. 90% of the students actually are eligible to enter the 9-month program. So that's basically the majority of the students. But unfortunately, there is no part-time basis, and that's because it's the program is structured, their deliverables, or things that you need to be doing in each week in order to reach the state and work that in order to present at these chapter presentations.
It's very much like the US way of master's degrees, right? I don't know, like Columbia's master's degree is like 1.5 years. I mean, they're like, they're like shorter period of time. So
yeah, it's only 9 months exactly. So it's very focused. We basically what we're doing is like we're tackling many complex tools, right? So there is no way for you to reach this amount, like this basically like state of knowledge and design excellence within really putting in the passion and the time. And it is super condensed in 9 months. So, like you might as well take advantage of that and just like get it done as soon as you can.
Yeah. So Henry's asking, if we want to go to the game, film industry, become 3D artist, tech artist, would this program be a good fit? And I'll say absolutely. We already have a few students who got reached out to from a game company, and a few have accepted that position because they're looking for like new and unique kinds of aesthetics and designs. So yeah, 100% absolutely perfect fit. Especially with like even like all the kind of metaverse stuff coming out too. That's like a whole other thing as well. A few of this people I know making metaverses even kind of joke to me that we're kind of like making like our course in the end is kind of making a metaverse, right? Like if you think about it, you're making like the characters, the environments, all this stuff. So pretty interesting that's kind of all coming up now. Architect wants to get into product design, more specifically furniture design. Would this course be appropriate for that? From Sumya. And I would say also absolutely yes. With this kind of computational design thinking, just like, I mean, I'm an example of that, of like the different fields I've gone to, and we've done also like the lamp that Helena showed, which is a lighting fixture. We've done our tutors we have in educators there, they're like Madeline, he's doing fixtures, and we also have done like and Shadar also is doing furniture. So absolutely, and we have in the second chapter, that's kind of part of the program, is to design this space and also like the products and furnitures in the space. Furniture meaning, furniture can mean like the word itself can mean like fixed stuff, actual movable chairs, stuff like that. So yeah, definitely, absolutely, that's a good place for this.
There was a second question from the same person actually about specifications. It's in the Q&A, so I just sent the same answer. through type and answer. But yes, basically, like the specifications are outlined in the Q&A portion at our website.
Yeah. Let's see. Do students have access to selected bibliography during the master's or some repositories? I guess that means like the library, right?
Yeah.
We have access to a library, online digital library from the university. How many day lecture part will take? Could you suggest us if the master program is suitable for part-time work? Okay, so I think probably mentioned, but it's about four hours a day for those like 3 weeks. It's 3 weeks, right? If I'm not mistaken. Or let's say 4 weeks per chapter, because there's also the theory. It's about 4 hours per day to be there. Now, the kind of like, it's a hard question to ask. Like, is it suitable for part-time work? Can I work during it? It's probably our most asked question, and it's the hardest question to answer because it really depends on you. We have students in our program now that work. We have students that don't work. I know a few students specifically that have like 2 or 3 jobs while doing this master's degree, and I honestly they're like machines, and they're honestly like killing it in this program as well. So that all really comes down to you and your time management skills as an individual. So we can't really say yes or no to that. It's something you have to kind of decide for yourself. But I will say we don't accept like that you didn't do your work because of your job as like a valid excuse to not have your work, right? So, if you have your jobs, whatever, they're your jobs. We don't really need to know about them. But there are people, absolutely killing it in our program that are also working. So. For current students who are the weekly wins, could you keep working at a job? Yeah, it's the same answer for same question from John. And again, it's our most common question.
There's also one about a group, if the projects are group projects or individual assignments. So for the chapters, as we said, they're around 5 weeks long, right? And 3 of these weeks actually are live, not consistent. The first, the third, and the fourth week is when we have these 4-hour sessions, right? But around, you're working with one more person, basically. So you're a team of 2. And there are some teams of 1 person too, but like we do encourage like group projects, and this is something actually quite important because you're learning a lot and you do have a lot of support, and you're able to do much more as 2 rather than as 1 person, especially when
That's a very common thing in most master's degrees. You'll be in teams. It's important. It's not only for master's, it's an important life skill, because in life, you're very rarely going to be working by yourself, right? And also, you're not really going to get to pick who you work with in life either, for the most part. It's a very important life skill to be able to do that. Also, the labs are individual though, except for the theory lab. But all the labs are individual because they're like more like, we feel every student should learn those things for themselves. But in terms of design, it's for the most part team and collaborative based workflow. And that's just, that's very common with masters, like Evelina is from the AADRL, and you were always with groups of like 3, 4, groups of 3 or 4. Yeah, so in most programs I know of in masters, just thinking about what's the other program, like the Vienna Applied Arts School, like they're always in groups of like 3, 4. So it's usually like that for masters. Do A and B groups have different faculty? No, you have this. It's the same faculty for A and B. They do both. They do both times. So yeah, it's the same. Both groups have the same access to everything. It's just that they're awake at different times, the students. But
That's
again, like
all the
it's
difference.
that's just like the in-person, like the course is hybrid, right? It's like pre-recorded technical, general technical tutorials, and then like hyper specific tutorials and critique and help on the design, specifically geared towards your design. But everyone has the same access. Teams and Miro are 24/7. Whenever, for instance, when I'm on there, whenever I see something, when I'm awake, I'll get in the conversation, I'll answer it, I'll help, so everyone has the same access. And A and B are not split up anywhere except for their live sessions. So they're in the same teams, the same everything. How many students are in the current? There's
38
30
students, yes.
38 students currently. Max number of students, I would say for current setup, I don't know what's the max.
Well, it depends, around like how it's set up. We're quite flexible actually, but I think that we'll be working with a very similar number, right?
Yeah, something around this 40. Ava said also, I never sleep. I am a vampire because I'm doing this master's and 2 full-time jobs. So let's see. Currently, I'm from Bangladesh. This is from Hassan. Currently a student of architecture. After my BArch, I want to go in sci-fi movies, virtual reality field or future. Is this course would help me? Yeah, I think we answered that already. It definitely that's it's kind of perfect for that, I think.
Yeah.
The perfect place, yeah.
How does fabrication learning lab online hands-on experience? I mean, what is the process? So the fabrication stuff is, I mean, obviously you don't have a 3D printer or, well, maybe some of you do. Some of our students had 3D printers and they were printing their stuff, but you don't have laser cutters in your home usually, right? So, or printers. So it's about basically learning everything, even about running the machines, setting up all of that stuff. It's just like the part that you actually print, isn't really happening, right? Because you don't have a printer, right? But
or it's cutting later from us.
Yeah, we do show that part, like, I think Dustin was showing some stuff like on his camera or something.
Yeah,
he was printing it and stuff and talking about like the challenges and what to look out for and kind of these kind of things. So it works just as you imagined it would work, except for the final part where you actually have the object in hand.
Yeah, and we do this, for instance, now we're setting up a presentation exhibition basically in the university here in Sofia live, and that's where actually the core leads are 3D printing some of those. So when they're needed, like for any purpose, we do 3D print the files. They have them as well.
So Sumia is asking, are the projects group projects, or we have individual assignment projects? Well, yeah, they're mostly group projects, except for the labs are individual. But the main focus is the design chapters, right? So
yeah,
we don't have all
but
these kind of.
There is something different about actually the way that we do group projects, right? There is a lot of I think that what's sometimes disappointing with group projects is if somebody is actually more proactive than the other partner. So that's actually an important thing to say.
Oh, yeah, that is an important thing, that each student is graded individually. I mean, we know, because we're like, just us and the tutors are hyper involved. I mean, we know what each student's doing, and so even now I can tell you the grades. Sometimes the team members get the same grades, but there's also a good amount of times where they don't have the same grades.
Yeah.
So
you're not, because contribution is very obvious.
Contribution is very obvious, and we care about it a lot too. So, yeah, your grade is individual, even though you're working as a group, right?
We have another question here.
It's the same. It's actually the same. You know, like just because we're from me and Paulina are working at Nike. I mean, it's the same with Nike, right? Like we're always working in teams and groups, but at the end of the day, your evaluation, right? Like every like half year, we get these evaluations right there, and we're kind of graded on our performance, and it's not based on. It's not like a group collective performance grading, right? It's per individual.
Yeah. And there is another question actually. Is there a special price or discount for Bulgarian students from the UACEG? Well, actually, we do have scholarships that we offer. So that's our way to help out, you know, and these scholarships are merit-based, right? So the portfolio you're submitting with your application, the application page is as simple as possible to gather the information that we need in order to run and basically evaluate. So we have a deadline of the 15th of February for scholarships. Also, there are a couple of different other options, and if you're applying with your friend, actually, if you're applying with your friend, they might be even your teammate in the program. That's one option actually to get a discount, or paying the full tuition in one installment. That's how you get another discount. So we do have options to help out, but they're not, we're trying to be as, you know, like as open and basically evaluating everyone by their skills. And that's why these scholarships are merit-based. They're not bursaries. So yeah, we do. Yeah.
No, I was going to move on to the next question unless you had something else to say.
No, that's the most important part. Basically, if the portfolio is strong, like that, you do have you know, good chance of actually like getting these scholarships.
And it's very important, the deadline, 15th of February, about those scholarships.
Yes.
Don't forget that.
Yeah. So CB is asking, have any students left the program because of time demands? So we've had only 2 students leave the program, and it wasn't because of time.
Yeah, it was,
they had their own.
Yeah,
they had their own personal situations, and we're still in contact with them. They still talk to us. They just had some personal things. So far, everyone's powering through it. So I'm actually really happy to see that. And that's why we have a few teams now that are like one person. Once out the master program, how effectively can we re-enhance or adjust a more pragmatic architectural setup?
That's a good one for you. We have some good experience from that.
Yeah, I don't know. A lot of these things really depend on you as an individual. You know, like we do what we can do, but also a lot depends on you. You know, it's kind of like, you know, give and take. We have to kind of,
no, but the most important part is that I think that one is the uniqueness of the design that you're getting through, you know, like this using this new software, new strategies, right? You have a new tool in your hand, and it's not one, but it's like, you know, so many different softwares, and this interoperability between them, it's enabling you to think in a different way. And because it's your own voice, your own interest, like we see the students are super passionate about their projects and they're really giving their all, right? And I think that that's what, like a lot, if your interest is more towards architecture and optimizing processes, that's something that like you could, you know, like use. For instance, I've had a job in New York working with really large scale developments in China, right? I wouldn't have survived this job if it wasn't for optimizing all my processes, for using Grasshopper, right? Like there is the client, there is, you know, like so many things that change. We're changing like each building every day. So you were changing like the heights of stairs, the, you know, like parameters, you know, these are the tools that actually saved me, really, like literally, not to be there 24 hours, because exactly like you can handle much more, not just, you know, like what your peers might. So that's really making a strong designer as, you know, like just thought process, but also optimizing processes, no matter in which industry.
So
I would add also that many of our educators are learning in a pragmatic setup, every day. And this is what you are using those skills for optimizing the processes.
Yeah, so Dino's asking how much work is done in groups and individually. I think we already kind of touched on that. It's mostly groups because of the chapters, but the labs are individual. Michelle is asking, is there any place where student projects of the first part are published? Check ourselves quality level. Thank you. Not officially, because we're still going. I mean, we're still going through it, so it's not officially published anywhere. But our Instagram stories and our highlights, like they're by chapter, and we share like so much all the time. So you can definitely check there. And then a few students going to present now. I just want to reiterate that this isn't an architectural degree program, right? This is not a traditional architecture program. So, you know, things are kind of like very out there and unique and new, but I think that's what makes it exciting. I mean, it's interesting to me because we've had like reviewers who are pretty busy people, like Chad Knight and Anouk and Oleg and, you know, Vulcan, you know, these kind of like in their own rights, you know, like, you know, distinguished people, and they're like basically always asking us, can we be on the next review? It was so much fun, like we love seeing the work, and they're just like, they're always like resharing it, and you know, like I said, like they're already getting job offers from various companies. So it's definitely like different and unique, but I think in a kind of refreshing way. And from the standpoint of like, what does it mean to be a computational designer and not, you know, just an architect or just a this or that. So a lot of things we see, like I honestly don't even know what to expect as the result when I get into each chapter, you know. And I think that's, for me, that's the most exciting, like when I go on these boards and I'm like, whoa, what is that? Where did that come from? You know, like that's what's really exciting for me personally, like being someone as a not student, as a, you know, on the other side of this program, is just seeing like all the kind of things people come up with when they're not chained to saying like this has to be an architecture as we know it, and even more so because, you know, a lot of our students aren't architects or specific types of things. So.
I think that what we can do is like go into some of the presentations of the students and then come back to more of the questions.
We have only like 5 more questions if I can.
Okay, because I think they keep coming.
Yeah, well, I'll go through them. What is level of Rhino? We need to already know. Where do you suggest we learn it? You don't need to know anything. A lot of our students don't know anything when they join. Like many of them didn't know anything. But we're actually doing something new in the next one. Is we're going to send out the kind of intro stuff beforehand, before everything even starts. So you could get ahead, like new students could get a head start on that.
Basically all the intro tutorials that are that we've put together, like we're going to actually send before summer starts.
Yeah, anonymous attendee asks, great presentations. If I may ask, who shouldn't be doing this course? I think anyone with an open mind and wants to kind of learn something new and kind of an unknown but exciting kind of realm of new opportunities in just work and career should join it. I don't know who shouldn't join it. I don't know. I think, yeah, I mean, if you're just not interested in doing that, then I guess you shouldn't join it. You know, like if you're just want to kind of be in a traditional kind of thing, then that's fine too, right? From Unreal Engine, Unity, which one most integrated parts of this course? Our last VR lab is with Unreal Engine. We're not doing anything with Unity. We're focused on Unreal, just because Unreal is becoming kind of like the industry standard in this, and especially in a lot of the metaverse projects. So there's just too many we can't cover everything, right? Every single software. So we try to focus on the ones that we see have the most potential for career. Our class is laid out considering time difference. Yes, there's currently 2 different times based on the different time zones, 2 different Group A and Group B. Also, how Airtable is integrated in this course, it is used only like a resource folder file. Airtable is used for all of our things, like all of our lists, all of our contact informations, the whole kind of program, the whole course outline, everything is Airtable. Grades, everything is through Airtable. So, publish some of the work before the deadline of February, just to understand which level we will reach.
You're going to see some exciting projects very soon. So
you're going to see them now, but they're literally all on our Instagram as well. So definitely check them out. Which type of software should I learn that will help me in this course in future after my BR? Just check our page. Every software we're using is listed there per chapter, so you'll see all the software we're using. And actually, in the Q&A is also like which software we'll expect to learn, and it actually just has a list of all of the software in the Q&A.
But what I would say that all softwares are applicable for all industries. Right, so it's not that, okay, I'm going to use this software from this chapter to this industry or that software. It just really depends on like what you land and what you're working on, right? But just like it's like tools in your toolbox, like, or colors, like it's just like it depends on you what you want and how you want to use it.
Yeah, Nadar was asking, this might be a silly question, but what is the possibility of turning some of the works we do during program NFTs? I mean, you could definitely, again, that's another avenue that you can go to it. I mean, we have a few students working on like NFT projects. I'm working on one with these skills. So yeah, I mean, it's just another avenue that you can go to.
But also I think that like here they're asking if they can actually take what they created in the program and make it an NFT, right? And that's like,
I think you specifically can't do that.
Or maybe you can, but we haven't researched it yet, so.
Yeah. What's the difference between attend courses and attend masters? Well, okay, a course is 4 hours long. A master's is 9 months long. Get a master's degree, you get 4 hours every day for a month with the tutor per chapter. It's just completely different thing. Like it couldn't be more different, right? Like the master's isn't just teaching the software, right? It's a whole design aspect.
And it's giving you the opportunity also to go into a PhD if you are interested in academia.
I mean, the webinars are good, like support, like even if you wanted to learn extra stuff, right? But the stuff in the webinars aren't here. It's different here, and
you are becoming part of a community, and you are getting a lot of contacts during the masters.
Yep, contacts.
And also job offers, etc.
Yeah, it's like
different.
Completely. I mean, a webinar is 4 hours. That's one day. If you imagine one chapter is like a whole month of that plus more, right? And that's just one chapter. And there's 5 chapters and 5 left. I mean, it's just, completely different animal.
And there is one more question here in the chat, actually. Are there exams or just submissions? So I'm happy to say no exams.
Yes, no exams. We don't do it. We're focused on what we're trying to do here, computational design. We're not doing extra stuff. We're not, we don't care about that. We want to focus on the thing we're doing, right? So there's no need for that kind of like extra stuff. And also like the application has no fee. It's a pretty simple application in general. We just don't want you doing like extra stuff just to say that you have to do it. Like that's not our thing. Everything we make you do or want you to do is with a purpose, for a reason. So we have 5 projects, and then there's one more there. It's a bit longer. Maybe we should save that one.
Yeah.
Help grid. Yeah. So all right. Let me. So I guess let's move into. Should we take a break? Do we take a break during these things? I don't even know.
Well, I'd say that we could do the presentations and
Yeah,
have
let's
some
move into
Q&As.
Let me find where's Iman and Anthony. Can you raise your hands just so I can find you easier in this list? Thank you. All right. Let me promote them to panelists.
Yeah, so basically the students are going to be presenting, we have 5 presentations and they're going to be presenting their chapter 1 and chapter 2 work. So that's like one of the questions that was asked about, like, you know, like how things actually are looking like. And you're going to see like that all the projects are super exciting,
Yeah,
very different one from the other.
There's no projects that are even, that was another comment we get a lot from our the critics, the reviewers. They're always like amazed, like how every project is just so different. There's not like a like same kind of project. And again, this is just a selection of, we have 20 different groups, so and they're all amazing in their own right. So Aman and Anthony, I don't know if you want to turn on your cameras.
And also keep asking questions, anything that comes to mind, we'll answer them after all the presentations. And if you have any specific questions to any of the teams also, please feel free. Hi, Aman. Hi, Anthony. Super excited to see you.
Super excited. Hello.
How you guys
Hey,
doing?
I was trying to get my DesignMorphine background. I couldn't find it.
It's okay. You're the special one here with your
Yeah, I got my curtains up and stuff like that.
So I just want to quickly ask, like, how are you guys doing? How are you guys feeling about the program? Just like short sentence or two, I don't know, just to start the discussion and move into your presentation. Yeah.
I think there's something you went over was the idea of working full time. And although I think me and Aman, we can say we both work full time, but it's just that this program is so avant-garde, I'm gonna say, because I've never seen anything like it before, and I've done a lot of like different courses online, and never seen something so organized and so like new and different. And you hit all the spots by saying you can go into any kind of new upcoming industry right now, in terms of be it CG, parametric design, and all that. I think it's an amazing program, and whoever has like second thoughts, don't just jump right in. And even if you have a job, just do it. You'll love doing it. So yeah, that's kind of how I feel personally.
Yeah, I mean, I'm always saying, like, you know, it's like 9 months, right? Like, it's not even.
Yeah,
it's
exactly.
Over, it's like over. It's over before you know it. You know, like, and it's just like a huge amount of doors you can open up in just like this short amount of time. You know?
Absolutely. Aman, I don't know if you want to say something.
If I may add, yeah, so before I joined the masters, I knew only Grasshopper a bit, so I wasn't really comfortable with any softwares, and I was always thinking that will I be able to, you know, learn a lot of softwares and, you know, improve the workflow that I have. But it's been like how many, like 4 to 5 months or 6 months maybe, and I'm like really comfortable with every software now, like including ZBrush, Houdini. So I've developed this sort of a workflow of my own. So yeah, I mean, it's really easy to learn with these guys. They're like highly professionals over here. So yeah, I'm really grateful for that.
Thank you for that. Yeah, if one of you wants to share, I don't know how you guys plan to do it. You should be able to share.
Actually, I'll share, and then we'll go through the
Sounds perfect.
as well.
How much time did we say we were doing each group?
I think
10
like
minutes.
10 minutes.
How much?
10 minutes per project.
Okay, try to keep it around that if you could.
All right, cool.
Yeah.
I will.
Hopefully.
Okay, so let's start. So again, if anyone got it, my name's Anthony, and Aman is my teammate, and we would like to present to you today Codex Recreo, a revised manuscript. Now, before I jump into the different chapters, I want to just go over what the whole idea behind Codex Recreo is. So, in the world we're living today in, our species is in a constant state of consumption. Although we produce more than we consume, it is not a sustainable and self-sufficient process. So our suspicions have led us to conclude that there is a correlation with the process in which our species has evolved to the modern day human. This has inspired us to explore a new model of evolution and existence through computational design. The basis of this idea is to simulate a synergy between the classes of civilization that maximize the use of nature around them, and thus evolve their realm into a better world with every cycle. Nothing is lost, yet it is reintroduced into this infinite loop around resources that are further developed at every iteration, advancing the entirety of humanity. Every connection in this chain has a purpose, eliminating the passive and bringing forth a regenerative system that forever grows into a better and more aware species. Can we rewrite the Genesis cookbook? If so, what recipes do we need? That's kind of what our theory in first chapter encompassed. And this is kind of like a brain map of how we developed the evolutionary idea of the simulation. Now, jumping back into what Codex Recreo is. Codex Recreo is a simulation of a parallel world. In this parallel world, instead of carbon, we have created something called a symbiote. This symbiote pretty much spurs life to a civilization devised and evolves into 4 main classes. The first class is a forager, which tracks and collects resources. The second evolutionary phase is an agronomist, which grows and multiplies resources, which later evolves into an alchemist, which fuses and optimizes resources, and eventually turns into an ephemeral, which fabricates, assembles, and creates bigger structures. Now, it's important to note that this entire system is, when we reach the end of the ephemeral, we are creating structures for the first foragers that come in to pick off where these ephemerals die and start all over. So for prosthesis, and prosthesis specifically, we focused on the first 2 main classes, which was the forager and the agronomist. These main first preliminary classes of the civilization utilize mostly the limbs and extremities of their body. So when we first started in this chapter, prosthesis, we first wanted to establish specific traits through models that better represent these functionalities that these humanoids would utilize. So we use tools like Maya, Houdini, ZBrush, a bit of C4D, some particle simulations here and there, just to kind of get a feel of how the symbiote aggregates around, or propagates, better said, along the body. So these were kind of like some tests, and over here we have some preliminary renders, just test renders. We wanted to try out color tests and so on and so forth. So once we kind of established the system, we kind of knew that, okay, this symbiote is kind of like aggregating or propagating around from the extremities of the back and flowing down into the limbs, the further outer limbs of the human. So we later then developed a generation process of each of these classes. The first class, given that it's the forager, we started to create these scanning devices and started to test different models and meshes around the body. And eventually, we kind of came up with these specific different types and functionalities for every single part of the prosthesis itself, in the forager specifically. So we have tracking sensors for the eyes to track for resources. We have a symbiote armor setup, some detection sensors on the arms for scrubbing for resources, and then which on the back is a resource collection unit, a scan meter next to the left leg, camouflage extension, and specifically a preliminary capsule unit on the right for storing seeds at the later phases of evolution. I think now Aman will walk you further through with the agronomist, which is the next evolutionary phase of our human.
All right, so I think we'll go a bit fast now. So the next one, we come to the agronomist. So the forager, he basically fuses with something called as the growth catalyst to create another class, which is the agronomist. Now, as you know, the agronomist, his main function is the growth capsules, and he keeps on growing these capsules around on the body. And these are some of the generations that he evolves into. So he has 3 different generations. And the next one, yeah. So in this, you can see a more exploded view of all the parts. Sorry, can you go to the next one?
This one here?
Yeah, this one, yeah. So in this one, you can see exploded view of all the, so these are basically the final renders which we have from the forager. So you can see his, and each and every generation, he has a different ability which comes with it. So for example, in the forager, the final form, you have stuff like the scanning, the collection, and you have all the stats showing like how much can he do in his world. And in the next, ones, you can see the agronomist forms. So in level 1, he has growth and transform. In level 2, he increases his abilities as the prosthesis grows on his body. And that's, yeah. And I think you can just show them the last one, which is this one, which is the final.
This is it pretty much. Yeah, this is the last one that we did. So this is kind of the last phase where we got within prosthesis, and I'm not sure how much more time we have, but we're going to move on to corpuscle and see if we can say everything. So in the next chapter, we wanted to mainly carry over corpuscle and show how the corpuscle itself evolves as well with the classes that further evolve in this world. So again, we are talking here about the symbiote going through every class. And our corpuscle specifically happens in somewhat of a barren land, something similar to the early phases of the Earth where continents started. We start with the forager unit, which is where the forager starts to dig deep into the ground and then starts to create specific small capsules inside the under the ground. And then the agronomist unit is an extension where he starts to build growth and seed generation pods at the surface of the ground. Further later on, there's an alchemist which starts to build these roots for the ephemeral, which sprouts upwards. A bit about the process that we took. So we took a base geometry and we've volumetrized it with some tetrahedrals and Houdini. We used some basic propagation rules to introduce these capsules embed them within the base mesh. Then we use the shortest path algorithm with a bit of a handy tool called the cost attribute in Houdini, which was able to give us more precise results and these nice branching, which we like to refer to as these tunnels that gave us really cool interconnected tunnels, which you'll see later in the sliced images. So our corpuscle is kind of divided into specific sections, and each section is inspired by something within nature. So as you can see in these references, and this is kind of the overall look and feel of the corpuscle. So basically our corpuscle is in constant motion. It starts from the surface of the ground, it goes underneath, and then it starts to surface again with the capsule pods, and then it blooms out as a flower. Aman, you can keep going from here.
Yeah, yeah. So this is basically just to show how the corpuscle syncs with the environment, where you have the first few stages, which is the forager and the agronomist. They're basically underground, and as it evolves, it basically blooms up vertically into the other 2 classes. And if you go next, yeah. So this one is basically showing as a sectional cut from the plan view, showing how the spaces are arranged inside a corpuscle, and it shows you the linkage of the forager, which is all the way at the bottom in purple, to how they link to the other classes in green, orange, and the last one is yellow. And yeah, the next one, next slide.
You're,
Yeah.
it's not changing?
No, yeah, it just changed. Sorry, yeah. So here on the left, you can see some of the sectional cuts that you can see inside the spaces, how the spaces are inside. And on the right, you can see some of the early initial visuals of how for the spaces of each class. So in the Forager, you have these very organic sort of a feel, where in the Agronomist, you have this sort of a void which the capsule gets fitted in. And the last one, which is ephemeral, is like more of a heavenly sort of a feel. And the next one, we just, yeah, so in this one, we were just preparing for the next chapter, which is the amalgamation, which is like just aggregation. So we were just thinking of very simple ways how to aggregate the entire corpuscle. And yeah, these were just some of the very, initial ideas. And yeah, then here are more of the exterior, the views from the corpuscle and how it actually looks with the color theme. Next one.
Some
The
renders,
last one.
just
Yeah,
some
some of
renders.
the renders that we have.
And this is mainly the final corpuscle from outside with the environment.
Yeah.
And that's pretty much it. Thank you.
Yep. Thank you so much.
Thank you so much. Amazing.
Thank you so much for your presentation and a glimpse into your work. It's amazing to me how much you guys did in such short time, especially like as Aman said, like starting with not really knowing much software. And it's only 2 chapters in, right? You still have 3 chapters to go, still have 3 labs to go.
Yeah.
a lot of exciting times ahead.
Now that you say it like that.
Yeah, when you look back, it's like, it's crazy. And especially when you look at like the work in progress boards, they're just like, for me, the work in progress boards are the most fun to look at versus like the final boards. Cause I just love seeing like all like the pre-work and like seeing how it started and where it came from and like all
Yeah,
those
exactly.
things.
Especially in Corpuscle specifically, I remember we did a lot of tests that we just threw out of the window, but they took us so much time to do. But eventually they became something completely different.
They're all
the
relevant.
process. Yeah.
They all get you there, right? They're like a stepping stone, you know?
Yeah.
That's basically 4 months worth of work, which is incredible, really, guys. Like,
well, not even 4 months, because that's really like 2 months, right? Because you also have the month of theory, and then there's like the month of like the 2 labs that they did as well. Like, so there, no, 3 labs. So
Yeah, it's been 3 labs.
yeah, it's kind of crazy, you know. I'll ask you a quick question before we move on to the next group. For current CVs wants to ask you guys, what was your previous experience in education?
For me personally, in education specifically.
Yeah, like previous experience in education.
Well, I studied 3D interactive arts in London in a design college, and then I actually specialized in character animation, which is something completely different. And then I started working in VFX, post-production, and yeah, I started getting into procedural design and compositing and VFX and stuff like that. But I realized that I've been using a lot of proceduralism. I got really in love with Houdini, C4D, and that stuff. That's mainly what my background is.
Yeah, for me, I came out from the architectural world, so I'm actually having a full-time job in architecture. And at the moment, because of the masters, I got another job in a gaming industry. So that's like.
So you're working 2 jobs and the masters. Huh? You're one of them.
Yeah.
And still killing. Both one of them.
Yeah. So for all of you asking if you can work and do it, again, depends on you. Yeah, so it's definitely possible. Okay, thank you guys so much.
Thank you.
I'm going to switch you back now to attendees. And bring the next ones up. Where's Ava? There you are. Let me bring Ava up here. Okay, well, Ava comes in. Anastasia is asking, are the team consistent through the masters or the partners switched? Your team is your team through the entire thing. Which is also nice too, because you kind of create this kind of
Hi.
bond. Hey, how are you doing, Ava?
Going awesome with a wonderful presentation.
Yeah, so glad to have you here. Before you start and we'll just get into it, I'd like to ask you, I don't know, how are you feeling? How are you doing? How are you feeling about this
Super amazing
program? I know you're always having a lot of fun in our
yeah
program. So.
I'm always hyper excited about it, and the best part is like this program is more structured well than I assumed before entering it. It was like very amazing for me to read those chapter heads, processes, corpuscle and everything, and it came out really well and very interesting. It's going like a big bang journey for me now, and the best part is like I know what I'm doing and why I'm doing, because it's not just aesthetics we are focusing on. It's like the theory lab that is structured very well before the chapters and pushing our everything that we design. So that's the best part. We are not just designing anything. It has a meaning and it has a purpose. So that's the very
and
cool
you
part.
were actually just telling me how you're excited because you're finally starting to feel comfortable with Grasshopper.
Yeah, the one thing that I've been avoiding all my life, Grasshopper.
So I was
if
really
you ask
happy
me
to hear
Grasshopper,
that.
I jump to Hoodie. If you ask me, then I just jump to ZBrush. But there is an end to it, and the tutorials are laid very well, so there is nothing to be afraid of. And the tutors are always there for one-to-one help, so nothing can you can't be scared of any software after you just come through this experience, I feel.
Yeah. So I'm going to let you share your screen and take your presentation.
Sure. I'll just stop my video for a better audio because I have a lagging Wi-Fi right now.
That's fine.
And I'll just cut it back after the presentation.
Sure. Perfect.
Sorry, do I share my screen or?
Yeah, just share your screen.
Okay.
We see it.
Okay. Hello everyone, my name is Eva, and I would like to introduce my project Immersive and Interactive Mnemonics. Memories are very crucial for humanity and have shaped us and our environment since our birth till today. So in our project, we are imagining a world where we can not only extrapolate memories as data from human brain, but also use that data as a pigment of art where everything is in a constant change. The focus of this study is to apply neuroscientific ways and available technology to propose a different way of perceiving the world. Using machine learning and Neuralink, we are feeding the AI stored in our external brain. Building aesthetic inspiration from hard surface modeling incorporated with organic skin, we started designing a central nervous system for processes. Our processes is named RAM, which stands for rendering all memories. It is based on the central nervous system of the body that reads all the different kinds of data and impulses that are shot by the neurons responding to different stimuli. RAM consists primarily two parts: the external brain that collects the data from all the locations of the brain that are vital for human emotions and memories. The second part is the external spinal cord that acts as a backup system for the external brain. It also acts as a powerhouse of the entire system. Human body is layered and connected with different transfer tubes that collects the neurons responding to various stimuli of memories on different parts of the body. The external brain is a three-layered structure that collects this data and processes for simulation. The first part of the brain is an EEG channel headware that records this data coming from different parts of the body and further sends to the secondary layer for processing. This layer is the functional part of the brain that translates this reading to a generative script by artificial neural network The second part of the processes includes the spinal cord, which is the stimulating structure that communicates cognition and simulation with each unique memory. This process generates an immersive and interactive variation of what we call realities. The external shell of the body covers the hard surface, collecting the stimuli and sends for the further processing to the onion layer of the processes. This process has an onion layer within itself, the secondary skin. This skin is mapped upon the muscles on the torso, which collects the muscle data. All the data that's collected is proceeded and made into complex patterns as simulations. These simulations will be controlled by the users. By following such a process of design, thinking, and functionality, we come up with this meta-human that has a new layer within itself, an alternate reality, as we say. A corpuscle is named as BIM, which stands for a bionic immersive machine located in the futuristic landscape of Tokyo. Just like the processes, the corpuscle is constructed around the idea of data collection and juxtaposition of the memories. We are giving building a way to be conscious and use the consciousness to juxtapose its own memories and sync them with the cyborg. At the external surface layer, there are a plethora of sensors which collect these data like temperature, pollution, along with the memories to allow for a smooth functionality of a residential unit. The corpuscle is divided mainly into the three zones that are the lab area, the Zen area, and the living area. The lab area is the part where human can remove their external layer of processes and keep them in pods while also having the ability to tinker with them and increase the suit's capability. This area also houses the vital systems for the module to function, as this will act as the external brain for it and computes its data. Zen area. Zen area is the simulation area where the user can either spend their time with their families or alone. This area will simulate all the memories of the users in that area along with its own. The living area of the module has all the functionality of a normal housing unit, as it also provides the users a personal space for their own simulations. The end goal of the corpuscle would be to aggregate with other modules and create a higher level of consciousness as it syncs the data, which would result in the juxtaposition of the memories. By the time a colony of BIMs become a reality, which will begin to spark as the new reality in the perceived reality. So this is the final output of the corpuscle, and we further go for the aggregation, and this is from my end. Thank you.
Thank you so much, Eva.
Thank you, Eva.
Thank you.
Such a tremendous amount of work, and we all appreciate it. And one of the comments people always make about Eva's work is how much detail is in it. It's just like very, very fine details. Even down, I remember in the, if I'm not mistaken, in the processes, you guys had like screws and bolts and kind of all these, very, very fine level details. So it's just really exciting to see you go into that, that level of thinking and detail.
And the best part is, like, I had not always been into this background of details or hard surface parts. Like, it was pushing my limits to something that even I was experiencing for the first time. And with all the help and every feedbacks that we got, it just came out so well. And like, we are really proud of what we do here.
Yeah, I think that's actually an important note for our degrees. We don't believe in these kind of like, I don't want to say like these kind of like messy projects. We want the models, when this comes down to like meshes and this that, to feel and be resolved, and we don't want these kind of messy things like self intersections and these kind of jumbled messes and bad topologies. So we do focus a lot on that, as well as kind of like things can look insane, but also be modeled well, right? Like they don't have to be modeled like junk, which is, I think you see a lot of this kind of like, it's very easy to hide things in rendering, right? Like, but when it comes to like actually having to do things like you know, in the last group where Armand was saying he's working at now, like a game company, like you can't get away with that, right? Like things need to be resolved. And that's something like in your models and in their model too, like, right, it looks crazy. But if you actually, you know, we've seen the models, if you actually open these things and look them around, they're resolved and nice and figured out. So I think that's really important. And one of the things that you're putting a lot of focus on in this program is like how to really, I remember in the beginning, you know, like when you guys first started, it's just a little rough around the edges, and we kept saying, like, refine it, come on, let's clean it, clean it, you know, like, let's make this a good geometry. So,
But that's what also, like, when you go, right, like for any kind of interview, like you send your portfolio in, like any, you know, like a specialist would see if the geometry is resolved or not, and that's your first thing, right? Like it takes time, it takes dedication, and actually that's craft, right? Like that it's passed on. And I think that that's what, like, we're super excited to see, Eva, that like you're really taking it to the next level.
Yeah, I still remember in the process chapter, I just designed a jaw just for the aesthetics without any meaning, and Pavlina kept pushing me. Why is that? I mean, you know, you have to have a why behind that, and just refer to the MIT research and everything that she kept pushing us, and we have answers to every why now.
this
So we are confident for any interview you throw at us.
This is a big thing in the program. I'm always asking every time someone sees something, why are you doing that? Why are you doing that? It doesn't mean it's bad. Like when I ask that, I'm not saying why are you doing that because it's bad. I just really I want to understand, and I want students to understand why they're doing things, or to at least even have a thought about it, right? Like, so like that kind of why is a big thing in our program, and you'll get asked a lot from everyone. Why did you decide to do that? Why are you doing that? Like, you know, and we're just really looking for answers and for you to think about it, you know, rather than just do, you know. I think we should.
I just want to ask one question. Actually, Eva, what was the biggest surprise for you coming into the program? Because you're in the first year, right? There were students before you to ask any questions or to see any work. Like, what was actually the most exciting thing or thing that like you weren't actually like expecting to see or to experience?
Actually, that was my opening statement. Like, I never expected it to be this structured and detailed a program, as like I came with the expectation, and with all the mentoring and tutoring one-to-one. That is like something, even if you're just walking by like a beginner with no background experience, you can ace it. Like if you are very dedicated to it, no matter you do a job or you are not doing a job, but if you're dedicated to this program, you can definitely nail it. It was like, this comes from my experience, and I'm very happy to help if anyone has any questions about it and my experience or anything about it. And if you have walked till here, there is no going back.
Yeah, so we yeah, I mean the you know the I think the important thing there is like I think it's fair to say that we'll kind of always give you the time you need, no matter.
Yeah, that's why I say that you don't sleep.
Yeah.
Well, with all the help and everything, he even manages to pull off the free webinars and workshops. We just discussed that he never sleeps.
Yeah,
that's the joke with Mike. We're just trying to figure out when does he sleep.
Okay, thank you guys. I won't take much more time.
Thank you so much.
Thank you.
Thank you, Eva.
So Michelle's asking, why don't we use Blender? Free, whatever. Yeah, I mean, we have nothing against Blender. Of course, it's a powerful tool, but we're focused specifically on industry standard. Right now, Blender is still too much. How do you say? I don't even know the word I'm looking for. Like kind of like small studio or like freelance kind of thing, which is awesome for that. But yeah, I mean, again, like we can't teach every single thing all the time. And also like Blender is like, if you know how to polygon a model, you can pretty much figure out how to polygon model in any software, right? So, you know, we could also say like, why don't we teach Cinema 4D, right? Like that's probably bigger in the industry than Blender. But for us, the biggest one and still is an industry standard in most VFX houses or even architecture is Maya in that aspect, and Rhino Grasshopper. So that's why we just focus on like the bigger of the big. But again, that doesn't mean that the skills aren't applicable. I mean, even like actually a funny thing, Ayub, who's doing the what is this role called? The core lead. He's filling in this month as a core lead. He actually takes, before we knew him and this, he was actually taking all of our CDNext and webinars, but following them in Cinema 4D. So he was doing everything we were doing, but doing them in Cinema 4D, right? So, a lot of these things are interchangeable, and there's just so much software out there. So that's really the only reason we don't use Blender, is it's just not the most relevant in terms of career opportunity at the moment. That could change, but as of right now, that's really just the reason why. We want people to work in the industry. Okay, let me bring the next ones up here. If you can raise your hands. Yeah. Oh, raise it again. Sorry, I accidentally picked lower hands. There we go. Promotes. Got it.
Hi, can we be heard?
Hello.
Hey, how are you guys doing?
Hi.
We're doing great. Very excited to be here.
Yeah, we're excited to have you. Yeah, before we start, I think it's a nice way to just before we just jump into the presentation. Yeah, tell us how you're doing. How do you feel about things? How are you feeling about the program so far?
For me, the program has really opened doors for me. I came from a construction background, so like anything but computers, I think, because I was always at the site. But a lot of things changed for me during the program, and a lot of doors opened, and I was one of those who were able to get a job in the gaming industry, and doing stuff in the NFTs is very applicable. The program is very applicable for many fields, really.
That's great to hear. Mohammed.
Yep. I guess for me, in simple words, it would be really like I get to really study and work with people that I look up to, and people that you admire who are like the leads in the industry. So I mean, the question would be like, why wouldn't you want to take this opportunity and start studying and start learning from these people who are really here to help you? So it's been really exciting. It's been an amazing journey, and it's still going.
Yeah, I mean, that's not to mention all of our educators, our leads are all also in like major offices around the world. And you have like me at Nike. You have a lot of people from like Zaha, Big, and just a whole bunch coming in. You can look them all up on our website. You can actually just click the names and you can see their profiles and about them and where they work. And, but I'm sure a lot of you know them already because they're all like pretty known people kind of in this field of computational design. So yeah, I'm gonna let you guys get into it if you want to share your screen. Okay, we can see it.
Okay, so we'll start. Deterioration, extinction of plant and animal species, planetary instability. In 2099, would we even need another Earth? Ladies and gentlemen, speakers, admin, guests, and fellow students, we, Alib and Ali, proudly present Exuvius, the anthro-cyborg metamorphosis, catalyst towards growth. In just 50 years, we would have managed to move ourselves out of the state that we were in the past 10,000 years. We have now moved from the Holocene to the Anthropocene, where humans are the primary drivers of change. We are already approaching tipping points, threatening the planet's stability and triggering an irreversible decay. We begin by identifying the 9 planetary boundaries as proposed by Johan Rockström, a Swedish resilience strategist, together with his team who developed a framework to identify the impact of human activity on our planet. Boundaries such as biosphere integrity, land system change, climate change, atmospheric aerosol loading, and biogeochemical flows are areas that we look at. As both human-driven and nature-driven disasters push these boundaries to planetary decay, we ask, could we reverse this decay? Is it possible to induce decay as a catalyst for growth? The purpose of this project is to explore the concept of anthro-cyborg metamorphosis as a core design principle that creates growth catalysts, targeting these critical areas and landscapes. The anthro-cyborg metamorphosis encompasses a harmony of anthro, meaning human, and cyborg, being symbiotic with nature and machine, creating a molting cocoon that grows the user, the environment, and the succeeding levels of design. The metaphoric cocoon is embodied by a molting exoskeleton, which is a feature among invertebrates, arthropods, various insects, and crustaceans. Through the exoskeleton structure, function, and layers, design principles are created to revolve around 2 main objectives. First, the exoskeleton is a growing medium that stabilizes and recovers over time. Secondly, the exoskeleton undergoes molting, wherein it decays into materials that are usable and upcyclable across all levels of organization. Through research of various technologies and organic bodies together with intelligent machine, it enters a state of symbiosis to form an exoskeleton. To induce molting, we introduce the principles, systems, and morphologies of the fungal kingdom, with varying fungal species that either decompose, enrich, sustain, or defend our ecosystem. With the ability of fungi to metabolize harmful substances and generate fertile soil, we catalyze a single spore to convert a desolate land into an oasis of life. The Exuvian concept featuring a molting and fungal catalysis influenced a wide array of material applications such as chitin and cellulose bioplastics, fuel and mycelium bodies, and other organic composites. The concept has also influenced systems of expansion, growth algorithms, aggregation function, and operating systems such as this self-aggregating and growing system we have adopted for furniture. Looking at the broader perspective of our Exuvian ecosystem, we have the prosthesis or the Exuvian suit worn by the Exuvian man, the corpuscle or the Exuvian seed, the Exuvian oasis seed, which is deployed from a kit housed in a rover called the Exuvian scrambler pod, the amalgamation or the Exuvian organism, the kinesis or the transport system consisting of the Exuvian scrambler line, and the cosmogony or the Exuvian ecosystem. Initiating the hierarchy of our ecosystem.
Enter the Exuvian suit, where man marries both machine and nature, where the first growth seed is deployed in severely deteriorating biomes, where no one would go, where rehabilitation is of the highest priority. We first examine the growth cycle and formation of the Exuvian suit, where the first Exuvian scout is deployed. We begin from growth attractors, which are placed onto the major joints of the body. These will stimulate the growth parts of the exoskeleton to be formed, which gives rigidity and endurance. We then place machine components which tackle a variety of vital functions which support and enhance the scout's sustainability. The skeleton now grows on parts mapped by the attractors, reinforced with fungal networks, adjusting through physical requirements computed from the different environments the scout would traverse. The outer shell, which is composed of bioplastics and other biomaterials formed from molten insect exoskeletons and other organic materials, now sprouts. With it, the skin emanates with improved performance on every mode and on every environmental condition. May it be the scorching heat of the desert, the numbing cold of the Arctic, the crushing force of the high seas, or the hostilities of the deep jungle. Underneath the shell starts the growth formations within a substrate layer, which promotes raw material production for the organic systems of the entire suit. The Exuvian Scout is set to tackle tasks such as resource gathering, traversing through difficult terrains, establishing a central nucleus point, deployment and growth of the corpuscle unit, and decaying its components and materials for the growth of the immediate environment and surrounding units through molding, rinse, and repeat until an entire cosmogony is formed. We have created an intricate and highly detailed organic and machinic system, working in harmony with man to achieve growth from decay, from the attractors to the machine components, to the exoskeleton to the skin, the shells and the substrate layer. Dissecting the suit, we look into the head, which leads the entire process as the central processing unit. Here we tackle communications, heightened visibility, and connectivity. The upper torso, which stores and processes energy from the biosolar cell-lined skin. The lower torso, which stores and processes dehydrated and organic food, both synthetically and organically acquired. The upper leg area, which processes human waste for recycling on one module and gathered organic materials on the other. Both components bridging the loop between production, sustainability, and recycling. The rear torso, which features the organic spine interconnected with the intricate loops of the exoskeleton. The modules contain compressed oxygen storage and processing on the upper side, and water filtration and storage on the lower. The hands, where growth is at the immediate bridge between the suit and the environment, adapting to terrain and sensitivity requirements on each excursion. Finally, the feet, at the immediate vessels to sense ground conditions. This area adapts to the immediate environment for mobility and traction. A deep dive into the inner workings and materiality of the suit. We see mycelium growth networks and other fungal species reinforcing both the skeletal and skin structure. The multifaceted shell structure composed of chitin and other organic materials forming a bioplastic composite. These growths are influenced by projected paths on top of the skin layer, providing a protective layer on each functional module embryo. Lastly, with these, the substrate layer forms an amniotic sac nurturing each and every embryo. Moving on to the next in our hierarchy.
We now introduce the Exuvian oasis seed, which exemplifies the fungal growth system. This system features varying fungal species which function as initiators for our ecosystem. With the ability of fungi to metabolize harmful substances and generate fertile soils, we catalyze a single spore to convert a desolate land into an oasis of life. We establish ground zero in a bushfire-stricken cliff in Australia's central region. Here, the Exuvian man is deployed as a scout, traversing challenging terrain and inhospitable conditions. Here, he identifies and sets up the first nucleus of the Exuvian rehabilitation. With his suit's molding ability, he can adapt to varying conditions and sustain himself. Enter the Exuvian oasis seed, where architecture is grown, where fungus initiates change, where man marries machine, nature, and structure, where the first growth seed is deployed in severely deteriorating biomes, where no one would go, where rehabilitation is of the highest priority. We first observe the deployment and expansion of the Exuvian oasis seed by unraveling the Exuvian scrambler pod. As the Exuvian man breaks ground with the corpuscle kit carried inside the scrambler, he begins to place growth attractors. These stimulate growth paths, regulating enzymes and moisture. From this fungal network, and spaces inside are formed. After a few seeds are grown, the network expands to create more complex structures, adjusting to functional needs and forming a community of growth agents. The Exuvian seed is composed of several layers of mycelium formations on organic substrate, packed by the Exuvian man and produced on site, reinforced with a synthetic interlocking granule aggregate, and enclosed in a bioplastic film as formwork. The shells, which serve as a roof, are derived from the same materials as the Exuvian suit, which is a hardened cellulose and chitin bioplastic. This raw material is abundant in insects, crustaceans, fungi, and other plants, which will be cultivated indoors. The exoskeleton which frames the structure's openings is of the same micromaterial, only less dense, to allow flexure in the soft bioplastic glazing when subjected to harsh conditions. The zoning and interrelation of spaces ensures efficient circulation, as the exuviant oasis seed not only acts as a habitat, but as a sustainable and resilient satellite laboratory, food production, material fabrication, and recycling facility as well. Spaces are grouped according to hierarchical lighting, ventilation, and humidity requirements. Areas such as the fungal cultivation needs low light, high moisture, and high heat environment. On contrary, the greenhouse would be effective at high light exposure. The autonomy and sustainability system supports an energy production room storing solar power from the solar cell-lined roof. The water filtration system and sewage treatment plant recycle rainwater and used water, and internal moisture as high heat atmosphere rapidly dehydrates. The dehydrating effect is used to an advantage in food preservation and food production in the food production zone. The composting, greenhouse, and fungal cultivation ensure suit and structure building materials as well as food are always topped up. A closer look at the internal growth of the furniture and fixture starts with a foldable granule aggregate that self-interlocks when activated and holds compressed substrate for mycelium growth. Paper molds are brought by the exuvian man to the site, which serve as formwork for both granules and substrate. After compacting the substrate, a cellulose and chitin sprayable film is applied to inhibit internal fungal growth. Finally, the other fungal species are added, which serve as insulation and padding. With the system we have researched, we have designed the mycorrhizae furniture collection for Exuvius, which is reconfigurable, recyclable, and deployable from growth. Altogether, these intricate and organic forms influenced by the function weave graciously around the immediate topography, exhibiting an exemplar of peak architecture and nature symbiosis, working in sync to achieve a singular macro goal: growth from decay. As we close, we would like to leave you with a thought. In 2099, would you even need another Earth? Thank you.
Thank you so much.
Thank you so much, guys. Awesome work.
Yeah.
Even down to the details of like all the furniture and all that. It's just really, it's really cool. I remember when I opened up the Miro that day and saw this whole furniture collection. I was like, man, what are these guys are going crazy. I could just tell that you guys are having a lot of fun, and I think that's really important to me. It's not that you're just learning and doing, but also that you're kind of getting into it and having fun and having your own ideas about things is really important for us. I also want to note to everyone watching and that will watch this that none of these groups knew each other beforehand. So that's really interesting to me as well, because I feel like you guys are all becoming like best friends.
Yeah. Yes.
Sure.
Yeah, it's just funny because like just to not know someone and then just to get so involved with them in a project is kind of really unique experience, I think.
We're like in a long distance relationship wherein you do the softwares with each other with a video call, and we're doing this right, does this look right?
Yeah, exactly. Really
and I think the program helps that with that. It really starts off with engaging us in a conversation where we really start to question very, very core ideas, where we come from, and really get to know, so that we delve deeper into these critical concepts.
Yeah, I think actually, if you remember, it seems so long ago, but it wasn't so long ago. In like the first 2 days, we basically had every student present themselves, but not just their work, also like their cultural backgrounds, what kind of things they're into outside of design, as a human, as a person, not as just like, these are the designs I made. Like, okay, we already know, you've done some kind of design or you're interested in design. We've seen all portfolios, but like, how can we get to know you better as a person, right? And these are also things that are important because it also helps to form these kind of groups and that, and also like where people
They're
live.
important information for the matchmaker.
Yeah,
Yes,
exactly.
Pavlina is a very good matchmaker, I think. So yeah, I mean that's an important part of this program as well. Well, thank you guys
Yeah,
so much.
it wasn't random, that's for sure, you guys. Like there was a lot of thought put into the groups, and really the passion and like the interest that you have, and yeah, we're really glad like to see this incredible work, but also exactly you forming actually, like friendships, and there might be so many other opportunities for you even after the program to really continue the collection.
I'll also like to add we have a lot of fun on Teams in Miro, like putting like memes and jokes and leaving little emojis and stuff around. I mean, it's a lot of fun, honestly. It's a really good time. So.
Thank you so much, guys. It's really like beautiful work. Keep killing it.
Yeah.
Thank you so much.
Thank you so much.
I'm gonna send you guys back now. Okay. Next one's Nadia. I see your hand up, but it's not your turn yet. Where's Sam? If you can also put your Alice here. There you go. All right. Let's see. Nadia got too excited. We're excited for your project as well. Hello. I don't know if we can hear you, Alice.
Oh, really?
Oh, no, yeah, we can.
Okay.
Yeah.
Hi.
How are you doing, Sam?
Hey, guys.
Hey,
Doing good.
guys.
Yeah. Yeah, so how are you guys feeling today on this Saturday? Doing good? How are you feeling about the program?
Yeah, I'm feeling really good. I think, I think it's just been like a really encouraging and inspiring atmosphere to be a part of. I think from all angles, like seeing everyone grow as a class, and then kind of getting all the encouragement from the professors has been really, really inspiring. And for me, like my background is a little bit different than a lot of the other students. Like I have a material design background, so I was pretty intimidated at first to be joining, but it's working out, and I'm still here. So, and,
I mean, Alice is working at Nike also as a material designer.
Yeah.
And it's just like, I think you didn't know any 3D software before.
No.
And now you're just killing it, right? Like, so it's really cool to see, to go from like material research and material design. Material. When we talk about material, we're talking about like textiles and stuff like that for like footwear and clothing. To this is like really, really interesting jump for you, and yeah, doing great. How about you, Sam?
I will have to agree with Alice. This is a very like inspirational experience, especially because you have like, I mean, all your classmates that are from everywhere in the world. We have like 100 different time zones, and everyone is like creating all these interesting things, and you get to see all that creativity put together. And at the same time, you have all these professors that are also like kind of like all over the world and kind of like constantly changing, and you get to be exposed to so many different things at the same time. That is, I guess, just a really like inspirational environment to be.
Yeah, I mean, and that, I think that's an important thing to mention too, is like in our program, nothing is hidden. Everything, like, as a student, you can see what all other students are doing at all times, right? Because of the way the Miro is set up, right? So it's nice to be in that environment, right? Like, it's not like you don't know what other people are doing, or like everyone knows what everyone's doing all the time. You see, you might pop on there at, I don't know, some early hour in the morning and see some other students' mouses moving around and maybe decide to have a chat with them or something, you know. So, yeah, so I'm gonna give it over to you if one of you wants to share and share screen.
Sorry for the
Great, we
noise.
see the screen and we'll let you get to it.
Okay, great. So hi, I'm Alice, and this is my partner Sam, and we're excited to walk you through our project EndoSim. So we seek to alter humanity's parasitic relationship with the world to a symbiotic one. And as we all know and experience very well right now, we currently live in a sterile environment where hand sanitizer has become our new friend and the ability to touch is becoming a thing of the past. So this led Sam and I to sort of ask the question of how can you experience touch without touching? And the truth is at all given times, we're never touching anything. And this is due to electromagnetic fields are the point of all interaction. And our brains have evolved to receive these electrons and process them into what is known as our senses. And this behavior can be exhibited in certain marine life that symbiotically utilize magnotactic bacteria to engage with their environment and surroundings. So this kind of led us to ask the question of, you know, how would humanity change if we could alter these electromagnetic fields? So we explored this idea with our project EndoSim, derived from the word endosymbiosis, being the symbiotic relationship of two organisms. And so we EndoSim is a module spine structure containing magnotactic bacteria and various microorganisms that symbiotically enhance the electromagnetic field of the host and allow them to connect with their environment, creating essentially a natural Wi-Fi. So we implemented a few different types of bacteria. Here we have the magnotactic bacteria, which have the electromagnetic fields. We have cyanobacteria that absorb carbon dioxide. We have the E. coli, which is naturally found in the human body. And then we have the biofilm, which is kind of a conglomeration of the bacteria that produce a film. And so this microbiome is hosted within a structure that mimics the human anatomy and is 3D printed with a combination of agar and microorganisms that is then fitted to the spine and will be the main center of interaction. And this structure will accommodate the individual throughout the human life. And Sam will guide you through this life cycle.
So taking a closer look to our prosthesis, the idea was to generate an extrasensory organ with the help of these microorganisms, allowing us to perceive and interact with these electromagnetic fields around us, creating a closer relationship with our surroundings, others, and ourselves through this kind of a natural Wi-Fi of electromagnetic waves that are being constantly emitted or generated by everything surrounding us. Here in the first stage, you can see that we decided to locate these 3D printed modules from agar in combination with the microorganisms over the spine, because this is kind of the main point of traffic of the nervous system in the body, where all the electromagnetic pulses of the neurons around the body pass through, allowing the microorganisms to grow out from this point and directly connect in a symbiotic relationship with the human being. And as we continue going through the stages of life, we can see how it starts as human ages, the microorganisms grow with it, slowly tightening kind of that relationship between the human and the organism as one entity instead of separate beings, and developing that extra sense to ultimately arrive to a complete fusion between the human and the microorganisms, as you can see here in the stage 7, where all the bacteria has grown to embody the human form as a second skin. However, as everything in nature has a start and an end, the cycle of life continues with the natural path of mortality towards a slow decay as we arrive to our final years of existence in the step 8 and 9, where we arrive to the end of the human cycle at death, just to be completely consumed and transformed into nutrients for the bacteria to regrow and flourish, starting again that cycle of life, where ultimately, at this point, our project becomes more than just an investigation on how do you touch without touching, and in a sense turns into a provocation, I guess, of two main truths that we constantly avoid. First, the mortality of our existence, and secondly, the unrealistic hypoallergenic world that we have created, in which we think that we live in these sterile spaces, when the reality is that we constantly interact with bacteria and other organisms surrounding us that live within us as well. So instead of trying to fighting them, we decided to embrace them, creating a new evolutive state on the humanity.
So essentially, this symbiosis is not only achieved on the prosthesis level of human and microorganisms, but essentially all relationships will be transformed to symbiotic, as you can see here for the corpuscle. The human-made base structure and the organisms create the environment for the humans, and all details down to the connection between units involve organic and inorganic life, as you will see, which will ultimately transcend to the entire environment. And now we'll walk you through the design details and specifications for the corpuscle.
Our corpuscle is basically a mixture of functions, a way to revive the dead environments that we have created in our concrete jungles and soils. We have created a combination of public spaces similar to the High Line in New York, and at the same time, an incubator of our bacteria that will clean the air and enhance the electromagnetic fields around us and our society. And in our prosthesis, enhancing our senses and as part of the natural environment instead of our current state of isolation. As you can see in this image, the placement of our corpuscle will generate the growth of our bacteria merging with the surroundings and being influenced and perhaps enhanced by the conglomeration of people. Furthermore, once in aggregation, this will create kind of a maze of public spaces through the cities from which the growth can be extended to cover large areas and create that fusion between nature and the man-made structures. The bacteria, as we saw previously, will grow around its surroundings, sharing its qualities, but as you can see in this image, it will also grow within the corpuscle itself, tightening the connections from one to another. The material that we have chosen work in a similar fashion to our prosthesis, where the duality of the man-made materials, in this case, the concrete, and a very resilient material is used as a base for the natural material, the bacteria, to grow and rediscover the symbiotic relationship that we have lost. And looking to a closer into interiors of our corpuscles, we can see that our whole program is focused on inviting the humans that interact with it to move, explore, wonder, and think. We incorporated a series of stationary spaces within a network of transitional spaces to invite people to gather, and thus the growth of the bacteria will be enhanced in these zones. As you can see in the sections, the experience is created into different levels of enclosureness as well as heights, creating this kind of experience, as you can see in the image, where you have the interaction of the bacteria, the man-made structure, the human, and its surroundings.
And the interior spaces are focused entirely on growing communal space in various ways. As you can see, there are communal dining spaces and work areas, all of which exist in this semi-outdoor environment in order to be a connection point between the dense city structures. The bacteria is prevalent in the interior spaces as well, and seamlessly connect the elements of the interiors together, as you can see in our detail shots, and here with our prosthesis existing inside. We landed on these structures by exploring patterns of growth in nature, similar to the way plants pollinate and grow, as well as lattice structures to host the growth using particle simulations and various grasshopper definitions reflective of these patterns. Similar to the prosthesis structure that served as a skeleton for the growth, the corpuscle will serve similarly in this manner. And humans will create a symbiotic relationship by contributing and nurturing their corpuscle with the bacteria hosted on them. This relationship is echoed throughout endosym, with bacteria as the integral connection between all beings as we evolve to be compatible with our environment again. Thank you.
Thank you.
Thank you so much, Alice and Sam.
Thank you, guys.
Yeah, awesome project, unique project. Can't wait to see what happens with it in the next chapter. As a kind of, you know, pun intended, it just keeps kind of growing and growing, right? Like with your bacteria. I mean, it's really interesting project. I love the theory behind it, and the process as well. Anything to add from you? Probably don't, or Stephanie?
No, I'm just super happy like to see you guys like exactly like having this unique voice and you know working so well together, and like you're both from totally different backgrounds, right? And like you're working so well, and exactly like this theory lab was where all these ideas like came to life, and now you're taking it from one level to another, and I'm super excited to see what a world out of this would be, and see the next chapters.
Yeah.
It's really unique approach, and this is the interesting thing in our masters, that all the projects are so different with unique approaches, and it's always so nice to see them.
Yeah,
Definitely. I like the aspect of the storytelling, you know, because it makes you really care about, you know, bringing something unique to your own project, and it makes you want to see where, like, how far you can push it. So it's exciting to have so much connection with the work that you're doing, and seeing it come to life as opposed to like individual separate courses.
it's important to have a goal and something to attach the skills to. You know, like I mentioned in the beginning, otherwise you're just making a bunch of random shapes, you know, like there's always kind of like the technical skills and then like the problem you're trying to solve, right? So the theory kind of like invents that problem for you to kind of attack with these skills. You know, in the workforce, your problem is going to be your brief, like what is the project you're working on, right? So it's always important to kind of have something to focus on, even when you're learning. You know, when I first started learning these things in Grasshopper, I actually didn't learn much from tutorials. Well, first of all, there wasn't many tutorials around when I started learning Grasshopper. It was mostly through like trying to solve other people's problems on the forum, like again, like having some problem to attach to and then trying to solve that problem. It's like really the best way to force yourself to use the tools and learn them. Well, thank you so much.
I have one question actually that came to mind. Like, I just wanted to know, how did this like theoretical framework and like all the conversation that you had from the beginning, because I know there were some intense conversation, meaning like you had so many ideas, you were going into research, looking into bacteria, trying to actually like even grow them. So I'm interested and curious of like, how did this like process went for you, and how did it enable you to get excited about the work and then, you know, use these tools to actually manifest it and visualize it, right?
Well, I think we really went through the rabbit hole, as they say, at the start. We started trying to like basically get like the main point of humanity in itself. We explored from philosophers, Nietzsche, Camus, etc., all the way to quantum physics to try to like understand what we wanted to like focus on and develop. And through the combination of both, I guess, is where we find out like the sense that you're never actually touching anything, because in quantum mechanics, like because of molecules rebellion, they are always like separating each other, so actually you don't touch things. And then like that became like a really interesting idea for us, the fact that like our reality is based or mostly constructed by the way we perceive it, but it's not per se the way we know it. And then at the same time, we kind of have like that, we'll call it kind of like sentimentalism of these like COVID times in which we are so separated and so isolated from one another. And we kind of like mixed the two of them and started wondering, well, what will happen if you were able to like actually interact with other people without like thinking that you're physically touching. And that's kind of like what brought us to like this investigation of how a better world, hopefully a more connected and less isolated one, will work.
Definitely, I think it was really nice opening with that theory because it really, I feel like we got to know each other super well through it. You know, we were just sharing so many articles and ideas, and it was such a nice way to like kick off and get excited about the work that we're doing. So it was really, you know, a very like exciting and interesting investigation. So.
Thank you, guys. Thank you so much.
Yes. Great work, team. Send you back to the attendees here.
Off we go.
Yeah. Okay. Nadia and Pedro, they're ready. Their hands are up. All right, let's bring them in here.
Last presentation for the day. Excited to see it one more time.
Hello, can you hear me?
Hi, guys.
Actually,
Waiting on Nadia.
I don't know what's happening there.
Yeah, she's coming in. Takes a
Yeah,
while
we are
sometimes.
disruptive as always.
Sorry about jumping in line.
How are you two doing today? And how are you feeling so far with the program and all that?
Well, you know, what I discovered on this master, at least from my perspective, it's that it's been really challenging for me in a way that it let me confront myself with the things that I used to believe before the master and the vision that I have to the digital tools, basically. So what I learned here is basically that this kind of digital tools that we are learning has this potential to change the way you perceive the world. And that's something that I found that's fantastic about this program. And finally, I just want to add something that even though we are surrounded by amazing tutors and mentors, I might say that I've learned a lot too from my colleagues here, from my friends here, because you know they are professionals. They come from different disciplines and industries. So that's another good point to be in this program. I learned a lot of some of them. Sure.
Yeah, that's true, Pedro. You have this passion about computational and advanced design even before coming to the program, but then I'm happy to hear exactly your perspective and how you're growing into it.
Sure.
From my perspective, I can say that I'm very pragmatical compared to my philosophical teammate. And when I first heard about DesignMorphine Master Program, I was in my kind of career shift. I transitioned from design, interior design and architecture to industrial design world. And I thought that it's just, I follow DesignMorphine webinars for a long time, and I trust these guys like completely. And they say that if it will push my career, it will push my design vision to the next level. I trust, and I joined without any second thought. I just jump into it, and I'm really happy to be here because yes, now I have cool friends. I have a community. I have amazing tool palettes of different software that I've never used before, like Maya, Houdini, and other stuff. And on top of that, I get my offer job of a company of the dream. Like I just all checkbox, you know, everything I had in mind before I joined the DesignMorphine Masters. For me, it's all checked out. Thank you, guys.
I'm really happy you got the job of your dream, and look forward to your formal announcement of it, probably through Instagram, I'm sure.
Yeah, no, super excited that you guys like have an amazing project. We're really looking forward to seeing it and asking you some more questions after it.
Yes. So yeah, I'll let you share screen and get to it.
Sure. I will do it. Okay. So time to get fun.
Yeah. I'll also
hello.
like to remind the audience that Nadia and Pedro have a very fun presentation style, so enjoy.
Thank you. Hello, viewers. Welcome to the DesignMorphine News, the only future news in past tense. Today with you in the studio, Nadezhda Kuturova and Pedro Venegas Rodriguez.
Hello.
What we are talking about today, Pedro?
Oh, how about mass extinction? Did you hear that the 6th mass extinction has already begun? Should we panic?
I'm not sure, but here with us, a design scientist who might have answered to how to save us all. Pedro Venegas, let's hear to him.
Yeah, it's me again. Split personality disorder, I guess. Okay, but let's begin. I want to introduce you to the Autonomous Living Machine Algorithm Project, aka ALMA project, the first experiment for a collaboration between humans and AI. You just need to know that all is about data. ALMA project is about the use of enhanced creativity for the sake of mankind evolution, a blending between human brain and AI brain properties working together to create a unique type of agent. 3 core attributes are explored on this process: communication, data exchangeability, and autonomy. These attributes will guide us in our journey through time, space, scale, even language. So we propose a model where invasive implants and non-invasive wearables work together, enhancing biological and synthetic senses to unleash a synesthetic experience of the host, creating the most valuable material ever: data. Data that is analyzed by ALMA using the connective map as a knowledge library. Our goal is to create a cyborg with biological languages and codes, thinking primarily in some of the most prototypical codes of nature, like transparency, translucence, lighting, colors, even sounds.
Let me introduce you to our first host of ALMA, Cusco, the astronaut, and Zoe, the choreographer, volunteers, of course. They collaborate with their ALMAs on daily basis. Through ALMA AI abilities, they enhance different senses and areas of their bodies. Here you see how, despite the very same principles at the core, their ALMA intelligence in biotics looks very different. To go further, we need to go back to the backstage of the design. We wanted ALMA to be friendly and approachable, and we saw it as something living. And here is our aha moment. When we covered an organic looking item with a transparent soft shell, we saw our ALMA. After that, we explore how ALMA could look like on all 3 levels of physical digital blend idea. And at the end of our design exploration, we developed a visual style that we called Bio-Baroque.
Different layers conform ALMA, starting with the main autonomous invasive implant, which is connected directly to the brain and the spinal cord, followed by the clothes or garments and sensors, which are those who collect data from the environment. Then, the wearable shells as the non-invasive extensions of ALMA, like the brains with the limbs. And finally, the physical data and digital aura, those who are the manifestation of what we call the soul fingerprint.
Let's have a closer look at our study subjects and see what kind of technology allow us to fabricate such design. Advances in multi-material 3D printing and data-driven material approach give us an opportunity to create personalized design based on characteristics of our heroes. As we push it further, we print with flexible bio-based materials with integrated vascular-like structures. It gives us comfortable to wear soft robotic pieces with microfluids inside to exchange the data. To visualize this inner data flow, we use bioluminescence. There are all necessary colors in nature already, and by mixing them, ALMA enhanced humans will be able to communicate on a new level.
In addition to that, ALMA also works with sensors that read data from the electromagnetic spectrum, from ultra-low frequencies like brain waves to ultra-high ones like gamma radiation, and sending this raw data directly to the ALMA main implant. Programmable materials technology is also proposed as the way for garments to work as big sensors, changing their form depending on external agents. For example, in the case of the astronaut suit and its transformation while exposing it to gamma radiation, signaling higher danger levels. Concerning autonomy, ALMA as an autonomous agent doesn't require to be connected to the internet in order to learn or take decisions. Here, it's where the edge computing technology is proposed as a base model for individuality. But collective properties are also introduced. After human lifetime, all the knowledge gathered by ALMA can be shared through a decentralized network, to be read or downloaded by other agents, such as humans, artifacts, buildings, cities, or even planets. Here, it's where the blockchain technology kicks off with all its potential. And finally, the digital aura, as the highest level of communication, is the representation of a unique soul fingerprint. This is the language of the interaction between humans and AI, the language of ALMA. And of course, much more things happen when humans interact each other, things we don't know. Maybe that's what emergence is all about, isn't it? Now, imagine the interaction not only between humans, but building cities or even planets. This is what we are researching right now. So stay tuned for the end of this experiment.
I hope this project will save us all from our doomsday.
Una eternidad más tarde. Ladies, gentlemen, and Miss Mars, welcome to your new dream home, the ALMA Corpuscle, where data is the key material for your happiness. If you have never heard about us before, let me introduce you to the story of our people, the humans. Not so long time ago, we, the Earthlings, overused our resources until we met climate crisis and mass extinction. To save the planet and our society, we enhanced our biological brains with an AI synthetic brain, achieving new cognitive abilities for the unique creative agent who evolved to what we are now. We use central nervous system implants and many basic wearables that they gave us the ability to collect and analyze the data of the world, enhancing not only our physical limitations, but our cognitive abilities. And now you are about to take part on this experience. Thanks to our core attributes, communication, data exchangeability, and autonomy, you can be part of this new ALMA society and experience it in all places, dimensions, and scales, from the individual to the collective level. So the ALMA Corpuscle is set on low Earth orbit, a place that belongs to everyone, a place where you can experience technological advancements, you can access to the data of the world, you can do tourism and experience cognitive shift thanks to the overview effect. This ALMA Corpuscle layout consists on the core sitting inside the womb that protects and sustains life, being protected and powered by the chrysalis shell, and a virtual shell for data sharing purposes. So let's have a look at the new ALMA unit Libit. Okay, enough dramatic pause. Let's continue. The best AI human artist has worked on this innovative design. They thought out every line of code of the algorithm that makes this project the most versatile unit ever designed. Algorithms such as differential growth, inflation simulation, structural analysis, optimization, and many more fused together with a bio-baroque style, very popular on Earth. So you can experience the solar system like never before, from the inside out. You can live in this beautiful living part of the corpuscle, the womb, a self-sufficient unit that can be detached from the chrysalis from time to time and support life. You can even access here to the most valuable piece of tech ever designed, the data library, where all humankind knowledge is stored and shared. But you can also stay connected to the chrysalis through airlock systems. So the womb can be benefited by the energy banks, store areas, and material production that lays there. Did I say something about versatility? Of course I did. The ALMA units are fully customizable. Their design is based on your personality, no matter who you are or what planet you come from. An astronaut on a mission or a sociopath from the dimension C137? Our corpuscle units will shapeshift to accommodate your lifestyle and personality like never before.
Let's have a close look at all features of your new home. First, exoskeleton. Our algorithms will produce a variety of structures and prepare the exoskeleton to withstand any gravitational needs. Next one, the inner volume. It's made from a durable and transparent composite material that will block harmful radiation. Inflated and pressurized interior will provide a comfortable space. Our state-of-the-art life support system will take care of the environment. It will timely replace old air with fresh, breathable gases, no matter what you breathe. The special light coding will show the current settings as beautiful interior decoration. As we mentioned previously, there are 7 airlocks, main one from the womb to the chrysalis, and up to 6 docking airlocks with 8 possible rotation angles. Connect anywhere with anyone. On top of that, we have a digital layer for ALMA communication. Your corpuscle can see and feel others in the settlements through digital aura, and through the umbilical cord, all information gathered into the core. Connect to the core through the spot and exchange data with your habitat, access the humanity knowledge library, or add your knowledge to the collective. In the living part of the womb, you can find 4 platforms: recreation area, private quarter, food production, and the control deck. Recreation area is designed in a way to accommodate family reunions, parties, or just for you to enjoy. Diet of noise and people, in private quarter, you will find a microenvironment with adjusted light and temperature to give you the best relaxing experience. Fancy terrestrial food, but no time for planetary shopping? Grow your own food in the food laboratory, from plants to meat. On the deck, you can control and adjust the ship system to your taste. And this is the jewel of the ship. The contemplation area is dedicated to overview the nearest planet and deep space. Behold the beauty of the life existence and appreciate the rare spark of life in the vast universe. Do you want to feel this experience? Order your living unit today. Call now. We accept morphine coins. Thank you.
Thank you so much.
Love the presentation.
Thank you so much.
Just a disclaimer: there's no morphine coins, so please don't.
Or now.
If someone has made a morphine coin crypto, it might be a scam because it's not from us. So please don't.
This is a good point.
Please don't go and buy some morphine coins because we
don't certify
it. Yeah, thank you so much. That was awesome as usual. All the teams today. Just a reminder that that's just 5 of 20 groups, all fantastic projects. But we can't sit here all day. And all super unique and interesting. So I don't know if you have anything else to say.
There is one question about software there. Just if you want to know, for our project, for the first part, the first chapter, we use just Maya and Keyshot for rendering, and for the second chapter, we use and ZBrush. Sorry, and for the second chapter, we use again Maya, ZBrush, and we introduce Grasshopper there. But our render part was in Arnold.
Yeah, we try to use.
I forgot to mention Arnold, right? Arnold and V-Ray. I always forget that.
Yeah, we try to use everything that software and the program offered us. We just literally try every render software we can use here, and every software we just play as much as we can here.
It's a great environment for that. Just experimentation. Well, thank you. I'll put you back.
Thank you so much, guys. Awesome project. I'm saving up to buy my own unit now.
Thank you, guys.
Thank you.
Thank you.
So that was it for our presentations portion. And I believe we've given all the information I can think of. I would just like to remind everyone to please check out the website if you haven't, in detail, especially that Q&A section too. There's a lot of things answered there. So I'm just gonna, of course, just drop the link here. Definitely check out that Q&A portion. Reach out to us anytime. We're always available. We do a lot of one-to-one Zooms, even a lot with our current students before they joined. We did it, and we've been doing it for the past few weeks now. A lot of meeting with potential new students interested. So you can always reach out to us at masters@DesignMorphine.
I just sent it in.
Yes, right. And just request a one-to-one. We're available, and it's really the easiest way to answer your questions rather than like text and back and forth. Like, just jump in a Zoom call with us, and we'll ask whatever you want, and we'll answer your questions. So definitely do that. Definitely check out Q&As. Yeah, and so does anyone, if anyone has any more questions, feel free to ask, or if anyone wants to ask a question like on camera or something, you can raise your hand. I can bring you up here if you want to go on camera, or just voice if you don't feel like using your camera, or feel free to type it. Yeah, we'll have a join us. It's a good time. So we really care a lot about creating unique designers with their own voice and who have a very strong skill set. That's kind of like the most important, I would say, for our program, is that you're comfortable with your own, with your own styles and development. John asked, I think someone said machine learning. We don't have any machine learning in this program because that's kind of like, to me, a bit outside of computational design. That's kind of like more into kind of AI. So I mean, that's kind of like a whole other field. And we've been thinking about that too. I mean, it could be interesting to have another kind of program around that as well. But that's a bit, when you're actually in this, like as someone that's kind of in this profession, it's a bit separated, even though there's maybe some overlaps, but it is definitely a different kind of field. So we don't, in this program, we don't have any machine learning. And then the anonymous one there, I don't know your name, but for the first part of the question, you're a current student at a large university. We'd love to help create a relationship between the schools. Feel free to email us, and let's, if you're interested in that, let's get connected. Because obviously you don't have your name there, so I don't know who even to reach out to. So just send us an email to like info@designmorphine.com. For the second part, is it any way possible without an application to get access to lectures and content? Our lectures and content are strictly for this, or for the students. However, we do have 2 students now taking the program without getting a degree, because I think they didn't qualify for a degree, but they didn't want a degree anyway. They just wanted to be part of the program, but they're still fully part of the program like any other student. So there's not like it's not like a shortcut or something, right? Like, they're doing the same work in the same teams. They're enjoying it just as much. The only difference is that they're not getting a accredited degree at the end, but they weren't actually necessarily interested in that. They just wanted, they didn't qualify, but they wanted to be part of this program, and yeah, they're doing awesome as well. So.
Well, yeah, and the whole idea also is that we are recommending you actually like to our community, even as you see before graduation. So that's why for us, the quality of the work matters a lot. So it's not about just, you know, taking some courses and, you know, like just chilling and watching some tutorials, and it doesn't really, you know, matter how much you really took from it. Here it does matter, because you are receiving a Master of Science degree, which is recognized worldwide. You can, you know, like go into academia with a PhD, you can continue to another master's, you can open your own office, you can, you know, go to work somewhere else. But also DesignMorphine throughout the last 8 years has become quite a strong name in the computational design industry. And it matters to us that, you know, like if you are part of this program, that you are actually, you know, like competent, you're actually really strong designer, because it actually helps you also navigate and be part of this community. So we want to be actually proud of you, and we want to, you know, create opportunities for you, and for you to actually like be the strongest designer that you could. And that's why we're so involved. And to be honest, I've been around a few educational institutions, and I can say that I haven't seen a master's degree that it's so involved, right? The whole community, all the educators, the core leads, like mentors, they're like so passionate about, like, you know, the program and what we do, and we care so deeply. And you can see that even with the projects of the students, right? Like this is 2 out of 5 chapters work, right? Like they're not even in the middle of their, you know, like journey, and they're killing it. And so many of them haven't even touched, you know, like software, this kind of softwares before, had experiences like that. So that's why for us, really, this matters a lot, because we want to see you guys really killing it out there. And that's the way.
So Henry is asking, what kind of work or portfolio are you looking for to get scholarships?
Good one. Well, I would say that like it needs to be something, right? Like representing your own voice and your own perspective, because at the end of the day, design is very personal experience. Like it's not something that you could just, you know, like copy from somewhere else. So this unique voice that like we're looking for you to represent, like as part of the program, like we want to see it in your portfolio. Software wise, I would say that like, you know, we understand that everyone is coming from a different background, but the creativity part is something that like we're looking into, and the care and love that you have for your projects, right? And also the personal statement that you're writing, that's very short, just one paragraph, but it needs to be to the point, right? Like expressing your interest, your background, and, you know, like your motivation for being part of this.
Yeah.
Even last year we had like a tremendous amount of interest, like right, and we had like only like 40 of these students actually making it even to the program, not just you know, like one part of the scholarships, obviously only really people with experience and like amazing portfolios, like they were awarded the scholarships, but also like even being part of that, it's actually something. And that's why I always recommend for you to put in your application as soon as possible, because it is, you know, like as applications are coming in, we're reviewing them, they're going through processes with the university. So it takes some time. So I would encourage everyone who is interested really to, you know, like apply, and definitely before the 15th of February deadline, because that's the deadline for the scholarships too. So your application will count towards reviewing the documentation, but also just adding a link to a portfolio. It's actually giving you the chance of, you know, being considered for a scholarship.
The degree or diploma that we receive at the program is from UACG, or we get DesignMorphine. And does the diploma mention the online mode? So the accredited degree is from UACG. You also get a certificate from us as well. It's the same thing, like what do you call it? The AA, right? Like the AA is also doing something like this, right? Like, so the AA is giving you a diploma, but they're actually accredited from
The
the
Open
accredited
Universe.
degree is from the Open University, right? So it's a pretty common thing that programs do. So it's very similar to that. Let's see. Storytelling appears to be a very important aspect of presentation. Is this soft skill explicitly taught along other mentors? Yeah, I would say it is, because we, the week before presentation, we're checking with you daily on actually the presentation and going over with you, like you're kind of like mock presenting it to us, and we're saying, well, like maybe you should say it like this and go in this order. So like we make sure like that the presentation is comfortable and organized with you as well. So definitely, it's definitely like, you know, I mean, you can tell like all the people that presented today presented very well, and I think it just comes from like also the experience of being in the program.
Because this is very important also in your work, to be able to present in the best possible way your creations. That's why we are trying to make it the same here with the masters.
Yeah, and also we're having something actually like coming up soon with actually even the students don't know, I was going to put it very soon, but we're going to have even a conversation about portfolios, how do you interview, insight, questions and answers about all that, because we've all been actually like part of, you know, like reviews and also reviewing others' work and also interviewing them, right? So we do know what an interviewer is looking for, and we're preparing our students throughout the whole program to be adequate, like, you know, going out. Like, first of all, you're going to have a full portfolio. And, you know, like from actually something that has to do with like fashion design or like the fashion industry, and then going into interior spaces, exteriors, and then, you know, like growing up in scale. So you're going to have a full book and a full portfolio, like to actually go into interviews, but also we're teaching the soft skills. And we also care about how you present yourself, how do you treat others in the program, right? Like we don't turn a blind eye if, you know, there are issues or challenges like arising between any kind of like collaborations or anything. And I think that that's also part of growing, right? So everything that has to do with you growing as a personality, as a designer, becoming stronger, that's something that like we care deeply about, and we are there in order to support that.
Yeah, you'll be fine. Don't worry. We'll make sure you don't fall. It's, you know, we want you to do good. So, any more questions? If not, we can let everyone go on with their day, absorb the information a bit, digest it, get back to us at any time. You'll get an email when this is done processing. Should be by tomorrow, so you can rewatch it. But also you can always by tomorrow, if you click the same button on the open day that you did to join, it will bring you to the recording by tomorrow. Right now it won't do anything until the video is done processing. Yeah, so glad you all like it. Again, this isn't your only chance to ask questions. You know, if you need some time to absorb the information, reach out to us. You know, the Instagram, we always answer Instagram. I would avoid Facebook because we very rarely check the Facebook messages. It's just not our main social media. We check them, but just not as often. Instagram we'll probably get back to within like the hour. Email, of course, and feel free to set up one-to-ones with us. So
yeah, we can answer specific questions also to your particular situation, right? So I think that these one-to-ones are helpful for that purpose. But other than that, I think that like you guys like got a lot of info from today. So such a pleasure really having everyone here and having this conversation. It would be awesome to get to know you better, and hopefully we'll see some of you like in the program starting in September. Thank you for the love and the interest, and we wish you really all the best with your endeavors.
Yes, and look, I hope to meet some of you in the next course. Always a good time. So.
Thank you so
Okay.
much, guys, for being with us, and looking forward to meet some of you.
Yes, and thank you to our students that presented today, and all of our students that are also in attendance that do, just everyone's just doing such great work. So.
And lots of love also to all the team of educators. We keep continuing this year, guys. See you soon again.
Yep.
Thank you, everyone.
Okay. Bye, everyone. Thank you.
Bye.